In my first night of being an Uber driver, I picked up 3 drilling engineers.
I have been selected by LinkedIn to be one of the very first LinkedIn Live beta users. And from what I know, this is the very first LinkedIn Live shot for somebody in the oil and gas business.
Your resume is doing one job, and that one job is to get you the interview. It's not to get you the job, right? It's to get you an interview.
Just yet. I don't know if you guys are afraid to ask Terry questions, but feel free to ask him. Anything is open. Is it often more difficult in large companies to push through new approaches, or is it more difficult to overcome the old school mentality?
So let me go back to the last question.
You guys are live on LinkedIn right now. Who wants to hold the mic?
Here more as a professional athlete, in my opinion, where like the hot take, it doesn't take me time to write about because all I do is read.
Shit.
There you go.
Battery died.
Hot take battery backhoes. Typical MWD hand. Battery died mid-job.
There you go.
Sorry, guys. Let me see. I'd have to call my mom.
Hi. I haven't seen you in a while, David. I haven't seen you since you lost your razor.
Here, you guys talk amongst yourselves for a second.
Oh, okay.
Okay.
I'm over there. It's like every other day, I guess.
There we go.
Oh, there we go.
I knew that there was going to be a pirate theme today, and I didn't want to be the only one out of it. And I am surprised, BJ, that you did not participate in today's theme.
Screw you guys. I own this costume. I own this costume. Like, screw you.
I hope you're out there watching today, and I'm telling the world that you're crazy.
Hello, everybody, and welcome to the show. And I'm blurry. There it goes. I've got autofocus on. Look at this. New camera. Oh, only slightly nervous because it's almost over. Hey, everybody. Welcome to it. This is the Push It, Point It, Rotate It virtual rotary steerable forum. This is the very first one that I've ever done, and I'm shaking like crazy. Anybody that's been watching behind the scenes has seen all of the madness that's going on. I have only got 8 minutes to be able to be on screen and tell you guys everything that I need to be able to tell you. So first off, let me know where you guys are watching from. What I'm going to do, hopefully afterwards, I'll be able to go back and look at all the different people that have told us where they're watching from, and I'm going to put it all in a map and try to color in each box and see if we can fill out the entire world map with where everybody's watching from. So a couple of things. If you guys are on YouTube, please, please, please hit the subscribe button. I'm trying to do a special project. I just need 1,000 subscribers to be able to broadcast live on mobile platform. I can broadcast live like this from a desktop, but I can't do it from a mobile platform. It's a small, simple request. Afterwards, feel free to just I'll just delete the channel if it's terrible. How about that? Then no more subscription, no more stuff, whatever. All right, guys. Wow, there is so much going on. I am so excited for everybody that's here. Wow. Okay, so I'm going to try to see whoa, that didn't even work. I clicked on the thing and these are going by so quick. I can't even Waco, Texas, San Antonio, oh my gosh, they're going in so quick. Oh my gosh. I haven't even seen how many people we got watching so far. 371. So guys, please share this. I'm trying to break the record for the most people watching a LinkedIn event ever, or just the largest oil and gas event ever. So we're looking to you guys to be able to help build this thing. So far, so good. It's, oh my gosh, I'm so blown away by all of the support here, guys. Thank you so much. I mean, I can't even keep up with how quick all of this stuff is coming in. This is crazy. All right, let's see if I can. Oh, hey, we got one there. Cape Cod, David Farmer. Thanks for being here. Thanks for watching. Oh, Scott Kessler, hey, in Colombia. Hey, good internet connection there, I guess. All right, guys. So for the first time, I keep doing this. Hold on. Boop. There we go. We're broadcasting live in HD, 1080p HD on LinkedIn and YouTube. So if you're on YouTube, you can change the little setting to be able to bump it up so that you can see. You can actually change the streaming ratio or whatever. So be sure to click that little button, put you in 1080 so you can see the beautiful background, not me. We got a lot of really cool things to be able to show you guys today. Obviously, this event is brought to you by DTech. DTech is our title sponsor, along with a whole bunch of other sponsors, but DTech was the one that was willing to take a stab and be the top company to step in there and believe in me that I could put on an event. Along with, I have to do special thanks to Neil Fletcher over at Rival. He was instrumental in being able to convince me to take this leap of faith that I could put something together like this for our industry, as well as the guys over at Kinetic Upstream were the very first company to sign up and be a part of this, as well as Katie Mills, who's the very first operator to be able to sign up for this. And actually, we are overbooked for the operators. At one point in time, Katie was like the only person, so I had to. I'm admit it. I did a Control-C, Control-V through LinkedIn like crazy, and I was like, hey, I just need people really bad to be able to step up and be a part of this. And people finally got around to answering the original emails, and then now I've got almost too many to be here. So we've got an operator panel, a domestic operator panel, we've got an international operator panel, and we've got an industry experts panel. So excited to have those on there. I am just talking as fast as I possibly can. We've got everybody. Okay, I can see everybody in the background. We've got all the stuff. We are going to do something really special. Where am I at? Oh my gosh. It's already 8:07. Oh no. I've got 3 minutes to do my presentation, guys. Holy smokes. This has all gone by too quick. Let me get this stuff off the screen. All right. I prepared this thing. I'm damn sure going to do it. All right. So we got to do this really quick. Nobody knows about what Gibson Reports is. So here's something you guys need to know. I'm begging the operators that are watching, and not just the drilling managers, because they all say yes. It's the legal departments that say no. So I'm asking the executives to pay attention to this. I want to be able to do a rotary steerable versus conventional data set. I need y'all's permission. We can do that, right? Days versus depth. We can do that. Lateral footage drilled in the U.S. on a weekly basis to be able to tell you exactly what's happening in our industry. We can do that too. We just need your support to be able to do it. So here real quick is your top 15 in the U.S. or in Texas based on MWD footage. Number 1, Gordon, Phoenix, Scientific, Schlumberger, Pro, MS, QES, Halliburton, Legacy, Cathedral, Total, Dixon, Baker Hughes, Premier, and then True Shot. Round out your top 15. Wow, we're already up over 600 people watching. April 1st, Luis Gonzalez, we're going to do an entire Vidor Locksmith show in Spanish. And then finally, with the last couple of seconds that I've got, Big Four only account for 13% of the total footage drilled in Texas. Sorry, not in the U.S., in Texas. Private equity, independents, and publicly traded round out the rest of it, all of them having at about 29, 28, and 30%. All right. So I have to do this now, and obviously I'm going to be starting a little bit late with the guys at DTech. They are going to be our first presentation. If you are watching on YouTube, right? If you are watching on YouTube, if not, if you guys want to switch over to YouTube real quick, we're going to do a drawing, a live drawing right here. You got to put in hashtag Gibson. Put in hashtag Gibson into the comment section on YouTube, right? I guess we'll see the numbers on LinkedIn shrink and the other thing go up on YouTube. If you put in hashtag Gibson, we are going to do a drawing. So I'm going to give you guys a couple of seconds to be able to do this. Sorry, Lena, we're starting a little bit late. We'll just have to shrink down one of the other sessions. So hashtag Gibson, you guys. Let's see. Somebody said something in the private chat. Yes, your background looks good. Thank you, Dana. I appreciate that. All right. Wow, the comments are coming in quicker than I can even keep up with, guys. This is absolutely amazing. All right. So back over here to this button. I'm going to pull this back off the screen. So remember, hashtag Gibson. I think we've got a whole bunch of them rolling in. Other thing. LinkedIn Live now has closed captioning. That's cool. All right. So, Dana, I'm going to go ahead and bring up the thing, add it to stream. I think we've had enough time for people to be able to click on it. Go ahead and do this, and then we'll see who the winner is right now. Oh, there's only been 19. You guys got to put in hashtag Gibson on YouTube. Otherwise, one of 19 people is going to end up winning it. All right, we got 23 coming in. The giveaway. You're going to get a Gibson Reports hat. You're going to get a Gibson Reports pauses. Oh, almost knocked something off my table. I'm already past. Oh, wait, no, I had the 2 minutes. Yeah, it was 8:10 is when they start, not 8:08. Okay. All right. Well, of those 40 entries, go ahead and hit the drawing. This is the first company. I have to say, it's a real special thing. Hold on. This is brought to you by StreamYard. StreamYard, the live streaming software. They are awesome. Big shout out to that team over there. I'm the very first person outside of their company to be able to use this. So huge thank you to StreamYard, Dana, and the team over there. Love them. All right, go ahead and hit it. Let's see here. And whoever wins this, I'm going to ship you a whole bunch of stuff. Let's see here. And it's Scotty333. I don't know who Scotty333 is, but Scotty, you are the winner. You're going to get a Gibson Reports hat. I'm going to grab you one of those drill bits. We'll get you a whole bunch of Gibson Reports swag, and then we'll send it over to you. Scotty, thank you so much. Do appreciate it. Wow. So fast, so quick. All right. First up for the rotary steerable, push it, point it, rotate it form is our guys over at DTEC. Thanks so much to having them here. And I'm only starting a minute late, staying on track here. After that, we'll have Rival, and then I don't even have my schedule in front of me. We'll go with it. Thank you guys for being here. Here we go. Lane.
Hey, good morning. Can you hear me?
Morning. Yes, sir. It's all you.
Hey, solid intro, man. I appreciate it. So no, thanks for having us, David. Really, I mean, thanks for putting this whole thing together. It really is pretty.
Oh gosh, sorry, Lane. I hit the wrong button.
No, you're good. Technical difficulty.
I had to mess up.
First time. So no, guys, appreciate you being here. Appreciate David really putting this thing together. A little about me. My name's Lane Magnus. I've been with DTEC a little over 4.5 years, almost 5 this year. It's gone fast. We came on in 2015 with our first commercial 6 3/4 tool. Quickly followed after that by a 9-inch tool and a 4 3/4 tool, and kind of have grown from there. A little about DTEC. All we do is rotary steerable. So, we don't do MWDs, bits, directional service, anything like that. We're solely focused on just the technology of a rotary steerable tool. When the tool was first designed, the whole idea was just to have a very simple, robust tool that could make it on land drilling. Back then, when this tool first came to fruition in the designer's head back in, the late 2005, 6, 7, when he started with it, it really was just about trying to keep the tool in the ground for land applications and trying to build something that's cost effective. At the time, a lot of you guys probably remember that the tools were very high end. A lot of them were being run offshore. Really cool bells and whistles on them, but man, when you brought them to land onshore applications in less than ideal rigs, muds, formations, you kind of saw a lot of problems. So that's really where the premise of DTEC came from. What we've been able to do over the past few years is really focus in on a tool it's strong, it's robust, but also really move into a tool that in the last couple of years really worked towards the finesse of the performance. So in how it runs, the ability to actually increase ROP, to be a smooth wellbore, and to really still be an economic tool. So let me share a presentation here for you. Let's see. Trying to, well, maybe. Here we go. If we can get it. I'm having my own difficulties now. So let's see. Maybe. There we go. Sorry, David, little technical difficulties there. But basically, DTEC's whole premise, it's a push the bit system. We divert about 7% of the drilling fluid into the pistons. We have a turbine powered tool, so we don't have any batteries in the tool. We have 6 pistons. We do pistons, not pads. The capability of the tool will give you full 3D wellbore control. Again, the whole goal is to be robust and durable, but also be low cost and be able to be a financially economic, tool that where there's not a lot of risk involved in running the tool downhole, from like a high lost and hole risk, or even just from the running of the tool, the cost of running the tool with, possible damages, post-run, things like that. That's the idea of it in the beginning. It is a short profile tool, so it does help getting in and out of the hole somewhat. And the big thing about DTEC, and I mentioned it earlier, of being just a rotary steerable company, is the constant evolution. So all we really want to focus on is this tool. A few years ago, I'll never forget sitting in a drilling engineer's office, and he was kind of like, well, why am I paying for your R&D? It's like, well, I mean, you kind of should be doing that with all tools, right? I mean, we should be constantly trying to get better and trying to find that next step forward. So I think, in the process of the conversation, I think you realize, I think you'd be more upset if I had just said, hey, it is what it is all we can do. Thanks for the money. We'll see you next time. So that's really what we try to do, is constantly evolve, and I'll kind of show you how we do that. And the other big benefit of DTEC is, being an independent tool company, we're not really tied to any directional companies. We try to service everybody. Anybody who needs a tool, we try to be there to help both directional and, operators and international applications. But part of that is, having 3,500 plus runs and 4.7 million feet in U.S. land, which is something that, we're pretty proud of for being, some of the small guys on the block. The introduction kind of the tool, what it looks like. This is kind of a general overview of the tool, kind of the big differences between us and, the other tools on the market. We are pretty short, about 12.5 feet long. Our collar is completely slick. The reason why we're able to do that is how we actually center our control unit and electronics package in our collar. We just came out with a new generation of tool, which I'll hit on here in a second. But the big thing on that is how we actually stabilize that control unit in that collar. It's actually got a patent on it. It's been a huge difference. I'll show you some data here in a second on what we've been able to do from the previous generation to the new generation of tool. And again, DTech, in the first few years, it was all about robustness and staying in the hole and just getting to TD. And that was kind of the goal, right? We made it to TD, good run, rah, it's all good. It's a great run. But what we found over the last few years is, man, we really need to take our performance to that next level and really be able to finesse this tool and work on the performance side of it. And so that's where this new generation of tool comes in. It really focuses on the performance aspects, not just the reliability and ruggedness side. The other big thing about the tool is the torsional strength. The steering head is something we put a lot of pressure into, being very torsionally strong, having a lot of hydraulic power. And the reason why is over the last couple of years, you see motors just getting better and better. A few years ago, motors were kind of, we thought they were kind of, we're at their peak, and then all of a sudden, new motors, new power sections come out. These companies keep coming up with new, technology basically that helps push that limit forward and forward. And so our tool at the end of that has to be able to, take that and use it, right? Not basically be an anchor for it, but help it, get better. So that's the big plus. The other big thing is the automation you see in the bottom left, that ink and as hold. That's something we have a steering mode on. It's an inclination and azimuth hold mode. It's been huge for us over the last couple of years. It's something we're constantly finessing, especially as we get into new applications. We're running faster in softer applications. And really what we're doing is constantly tweaking. And that really allows us to almost customize the tool per a customer's, specific application. Downlinking, really simple. It's kind of the general standard. It's kind of boring. But it is what it is. I mean, you see in cold 2 at the bottom, we fluctuate pumps 15 to 20% to send our downlinks down. Downlinks are anywhere from 7 to 15 minutes, depending on what we're doing. This is a big part of the new tool's evolution, is trying to get these downlink times down, as well as just reduce the number of downlinks you actually have to send during the run. So that's a big part of what we're trying to do as well on the new tool and the software, which I'll hit on. So mentioned we hit 2015 is when we first started. 2020 was a big year for us, as terrible as it was for the world. And for our industry as a whole, we kind of took that next step on the performance side for DTech. I mentioned we hit 4.7 million feet, which again, I know it's not much in the grand scheme of things, but for a little company like us coming this far from an idea on a piece of paper, it's something we're really proud of. We ventured into the offshore world with some really good learning runs, good performances. Really able to dial that in. Our longest successful downhole run in the Middle East was 227 hours of circulating and drilling time, which was huge to prove the longevity of the tool. Another thing I'm really proud of is the number of engineering initiatives at 37. I talked about never being satisfied and continuing to work and evolve. Our engineering team basically changed 37 things on the tool to get us to that next step, next generation tool. And these are all things that were from design to implementation to the field testing, very big things for us, as well as, the length of these runs and the speed in which we can do these runs. But the big thing is, even in 2021, we've already just done a 4-mile lateral. So we're continuing to push that and continue moving forward. The next gen tool focused on these things. These are what we really wanted to focus on. We wanted to have a tool that could run higher than 330. We've actually got it to 350. We wanted to change the resolution on the tool to 0.5 degree increments instead of degree increments, which is what it was before. The 60% decrease in downlinks. So basically what it used to take us to drill a 10,000 foot lateral, we've reduced the amount of downlinks it takes to get there by about 60% on the next gen tool. And a lot of that has to do with the software and hardware we've changed inside that control unit, and how that control unit sits in the tool. Components now rated at 220 Gs. What this meant is that we used to see some tolerance stacking, some flexing inside the tool at less than this level. Obviously, as you do that, your longevity in your tool starts to degrade a bit. So this is something that we really worked hard on to reduce that tolerance stacking, get that strength up, and so that way you've just got better performance and longer tool longevity, as well as component life in the tool. So you're not having to retire things as fast. The biggest thing, this 8 data points sit in real time. So our tools, we do have real-time connectivity with a few different MWD companies that we're getting out in the field right now. We're able to pump up any of the 50+ variables our tool is recording. So we can pump those up in real time and see them things like, different tool health diagnostics, inclination, azimuth. You can see different shocks, things like that. So it's huge on the real time to be able to get that information at surface and be able to make changes as needed. I talk about increasing the performance. This is something that we do post-run every single run. Being a rotary steerable company, this is all we do. We basically look at every single run, do a full report based off our data, the MWD data, if we can get it, the surface data, put a full comprehensive report together, not just for the customers, but for us and to learn. This has been a big portion of us trying to advance the tool and really being able to take, the advancements we're making on the tool now. 4 years ago, 5 years ago, they were done with machetes, right? We're taking huge hacks at things. Now that doesn't work, change it. Now we're really doing things with scalpels, really trying to finesse the performance and find that, that perfect line that makes it easy to run, but still rugged and robust enough to make it to the end and not have to worry about it. So this is a big part of it. We try to have this done as quickly as possible, but with the real-time advancements coming, these can actually be done while we're drilling. So we can actually get some of this data and start putting these reports together while the tool's downhole for the customer. So that's a big change for our company going forward. You can see here top run, this is basically a first run, and this is one well. This is the first run and the second run. First run's up top with the previous generation of tool. Second run's on the bottom with the new software and new tool. You can see how much cleaner it is. It's just a lot cleaner, a lot less shock. I know people are gonna say, oh, the scales are the same. But basically what you're able to see is the tool sees a lot less shock because of how we've redesigned some things inside the tool. It cleans up the data. It makes the tool face control on the tool much better, much easier, much smoother. Basically what this translates to is a much easier tool for the directional driller. Not having to put as many inputs in, not having to worry about, as he's seeing his continuous inclination move, it just makes it a lot smoother for him or her to basically find a way to get the TD with less work and less stress on the VHA as a whole. So this is kind of a good representation of where DTEC's been to where it is now. The left is where we started. I mean, pretty rudimentary design. The one right to the next over, that's kind of when I came onto DTEC, and that was where it was like, hey, let's make it to TD. Where we are now with the performance, I mean, you're talking, almost triple the hydraulic force behind the pistons than we had in the initial ones, as well as dogleg capability, ability to stay in the hole. It's just a 9-day different tool. Some of the things we're working on, we talked about the MWD integration. We talked about, remote downlinking a little bit. The big thing is down. I think one of the questions you had on LinkedIn was actually integrating into the rig automation. That's something we're already doing with a few. We're developing a high temp tool with also drop-in gamma capability, so that's coming as well. And then some enhanced automated drilling capabilities, being able to just press some buttons and have the tools do some things and find certain things, making it very easy continuing to evolve that process to make it easier to run. Our shop in Houston, nothing crazy. We're located here in Houston for everything in U.S. land. It's definitely something that, if you guys ever want to come by, see the shop, more than welcome to. We'd love to have you. Again, our whole premise at DTEC is to try to be a simple economic tool, try to be easy to use, try to be transparent. Our whole goal is to make it, make it worthwhile, return value, right? I mean, sometimes you talk about conventional versus the rotary steerable model, and sometimes, what we found is sometimes it doesn't always make sense. We're not trying to put a square peg in a round hole, basically. So it's something that we are trying to work on to make sure that we continue to evolve our tools, and I think everybody is in the rotary steerable market, to try to keep up with that. As conventional gets better, we try to keep the ruggedness up, keep the reliability up, try to make the tool as simple as possible. And again, I think our tool does a pretty good job of that. There's 12 moving pieces and 6 are pistons, so it's like I said, it's pretty basic. But again, that evolution of the tool going from just a basic rugged, hey, let's ride this thing to TD and get it in, going from that mindset to really trying to finesse and get the data points to where, hey, this is an easy tool to run. The wellbore quality is really good. We're able to drill very quickly and some very fast formations. That's been the big progression and evolution of DTEC over the last couple of years. And a lot of that has to do with the directional companies that we work with. I mean, they're constantly sharing stuff. I mean, I think collaboration with rotary steerable is a big part. I think that's where some of the independent tool companies like us, maybe you're kind of a step behind just because we don't have a service company to just piggyback on to say, hey, what'd you see there? What'd you find? What data did you see? What damage did you see? So those are things that I think we're very grateful to have those partners and those friends in the directional world, as well as the operators who kind of want to dig in and share and continue to get better and push rotary steerable forward. And I think we can all learn a lot of lessons from each other as we run. I mean, you know, the competition's great. It's always fun to be on a well, and the well next door, the rig next door picks up another tool, and you get to really compare, hey, here's all the changes we've made on our tool to what they've done, and you can kind of see it. So I think rotary steerable is kind of, you know, it's come a long way in the last 5 years. It's kind of a ton in the last 10 years from when I first started in the industry. But it's something that we're excited about, and obviously DTech appreciates the opportunity to be here, David, and look forward to seeing everything else and what we can do.
Lane, thank you guys so much for being a part of this event. I truly do appreciate it. Anybody out there that's watching, go check out the DTech website. Get in touch with these guys if this is something that you're looking for, or at least just to be able to educate yourself a little bit more about the tools and the technology in the industry. Once again, Lane, thank you guys so much. I really do appreciate you guys having faith in me to be able to put this thing on. All right, guys, next up, we have got a quick presentation here from the guys over at Rival. So let me make sure I can do this right so that I don't mess up. First time trying to do this, so here we go.
During today's event, we're going to get to see some of the newest technologies related to rotary steerables. We're here today to talk really about our motors and how they can help rotary steerables perform today. To do that, we thought it would be a good idea first to kind of talk about where the market's been for motors and rotary steerable, how it's evolved over the last 20 years, so we can all understand where it's going. So zooming back out and going back to the early to mid 2000s when rotary steerable was first coming to US land, rotary steerables were deployed to target specific application challenges, represented a low single-digit part of the market, and were adopted primarily in vertical and lateral sections to begin with. There was a split between RSS only work and motor-driven RSS, with the MWD below the motor. And this was really our first generation of rotary steerable motors in the market. These were essentially conventional motors that were reconfigured to become rotary steerable motors, typically just deploying a straight housing, maybe an adjustable set at 0, and throwing a pin down connection on the lower side of the motor. Moving forward into the 2010s, we saw a lot more market adoption happen with rotary steerable. The rotary steerable started to expand to most basins, and market share went up to roughly 10 to 25%. RSS curve technology got deployed during that time, and RSS became one of the primary choices for extended reach work throughout the country. During this time, using motors to drive RSS was greatly expanded, and the MWD shifted below the motor for most rotary steerable work. This is really where the second generation of RSS motors comes in. And what I mean by that is that RSS begins to shape the motor design. We start to see some larger tools developed to help rotary steerable, flex shafts coming out from more and more motor companies, bearing improvements, all to support the rotary steerable. And then moving forward into the 2020s, we've really seen a big market expansion of rotary steerable. Now we're looking at 25 to 30% of the market using rotary steerable on a regular basis, and that number is growing. RSS is now common in all sections, including curves, and it's a normal thing nowadays just to see many curves TD per month using rotary steerable. Motor is now integral to the RSS BHA design. So whereas before the motor was kind of viewed as an option and most people viewed it as a performance edge, now it's essentially standard, and nearly all rotary steerable runs happen with the motor in US land. That's led to the third generation of RSS motors, where RSS is driving the entire design of the motor, and motors are actually being configured to the specific RSS application. So whereas in the past, we had some development tied to what the rotary steerable required, people would tweak their designs or make a module that was focused on the rotary steerable. Now the entire motor design is really geared towards rotary steerable, and it does bent work also, rather than it being primarily driven by bent work with a slight focus on rotary steerable. We've also seen in this third generation, as I mentioned, the motors begin to be configured for the specific rotary steerable application. So whereas in the past, they were generally undifferentiated between vertical, intermediate, curve, lateral, rotary steerable motor setups, now companies are starting to come out with specific curve assemblies, specific lateral assemblies that are more aligned with what the BHA is going to do downhole and how the well is planned. At Rival, we've built the largest independent fleet of rental RSS motors in US land with over 350 active assets. These are mud lubricated bearing assemblies with RSS tuned radials for bypass management, hardened thrust bearings to handle the high off bottom loads that RSS and MWD systems below the motor put out, driveline options which are geared to match the application, deploying flex shafts, radial flex shafts, and articulated flex shafts into rotary steerable applications based on what section is going to be drilled and what the client's goals are. And then using premium alloys to achieve design targets within the envelope. The motor isn't really able to grow much beyond what it is today inside of its current hole size. So we've really got to deploy improved alloys to get the performance out of the assemblies that the RSS now requires. Recently, we acquired the hunting energy services fleet within US land, which really adds to Rival's RSS position. This adds new power section options that allow us to pair up hunting energy services power sections with the Rival lower end fleet. It adds the endurance lower end, which has a fantastic track record in rotary steerable applications in US land already. Internal manufacturing of RSS motor components, which will help enhance our time to market on new research and development projects, and new deployment locations in Wyoming and Pennsylvania. With this fleet of third generation RSS motors that we've built out, it's allowed us to gain a ton of experience in rotary steerable applications in US land. In just the first 36 months since we started renting tools, we've already had over 2,000 RSS motor runs and drilled more than 9 million feet across basins. That includes runs with all major RSS platforms and a lot of curve lateral runs out in the Permian. To do this, we've developed an approach that we think works well for US land, considering the amount of people involved in a single RSS project. We work with the E&P companies to understand their goals, what they're trying to develop in terms of their drilling program, through the directional service provider to understand what the other requirements are for their tools, for their MWD, and how they intend to set up their BHA. We work to understand the original equipment manufacturers of the RSS's design requirements to understand how that might impact downlinking, how important bypass management is to them. And then we optimize motor selection and configuration from within our portfolio to provide the best options back to the entire team. We've got about 5 different lower end options we can put into any hole size. So understanding how to pair those lower end options with the right power sections to drive them and ultimately drive the bit is what we've really tried to do as we work through our directional service providers and ultimately deliver performance at the well site. This next slide will kind of go over some of the different options we've got for the smaller slim hole work out in West Texas, and then also the 8.5, 8 3/4 inch hole size, and where some of those differences come into play that we work to manage. This overview shows 4 of the main options we use in the Permian to drill with rotary steerable today. This includes 3 different power sections deployed on 3 different lower ends. The key here to recognize is that each lower end option and each power section is going to have relative benefits compared to each other. So something that's more flexible might be better served for a curve and lateral planned run, whereas a more stiff rotary steerable motor might be the best option for a lateral only, where it's all about tracking and we're not trying to build angle anymore. Moving over to the 8.5 and 8 3/4 sheet, You can see some of the other options here. We've highlighted 5 different models across 2 different bearing pack assemblies here, and including our 712 7857 with a radial flex shaft, which is our premier choice for West Texas curved lateral assemblies. It's also equipped with a flex housing to complement it and give maximum bending capabilities to the assembly while still being able to make it through the rest of the lateral and TD in one run. So those overviews kind of give an idea of where the market is today. We're excited to have a really big fleet of 3rd generation rotary steerable motors to offer. But in terms of looking forward at where the market's going, down the road and through the rest of this decade, we're really looking to that next generation of rotary steerable motors where we evolve one more step further. Now, instead of the motor just being primarily designed for rotary steerable, it's designed exclusively for rotary steerable, and it'll never have a bend on it. That's where motors like Rival's rotary steerable motor come in, which provide all of the benefits of an oil-sealed motor, providing all the pressure and flow to the rotary steerable system and drill bit, while maintaining a mud lubricated bearing assembly for maximum reliability and durability. The rotary steerable motor also uses our most advanced flex shaft designs and a number of other improvements based on our experience in the 3rd generation of rotary steerable motors. We recently secured a patent on the technology in Q4 of 2020 and are excited to offer this motor to the market moving forward. And with that, we'd like to open it up to any questions.
All right, guys. Sorry about that. We might have seen just a little bit of technical difficulty as that was playing through. Many apologies. But if you guys have got some questions, oh man, even my mouse is moving a little bit slow there. All right. I know that you guys have been watching this. Thank you guys for being there. If you guys have got some quick questions, let's be sure to get them in. Let me get caught up here. Let's see. All right. I should just say this. Guys who are at Rival, do y'all have anything y'all want to say?
No, just thanks for the time, David. Great event. We're super excited to be here. We mentioned during the presentation, we just acquired Hunting Energy Services motor fleet in the U.S. It's been a really big undertaking here at Rival, and we're really excited about what it's going to allow us to do. So we'll be deploying tools in the Northeast out of Casper, integrating the fleet into our offering, and finally doing our own manufacturing for everything from flex shafts to radial bearings. So we're very excited about what it's going to do for us in U.S. land with our motor fleet.
So we do have a question from Chris Marlin. It says, do Rival make their own power sections or they bought from another third party?
We work with third-party power section providers. We do a ton of work with, I'll shout them out, Dynadrill and Abaco are 2 of our primary ones that we use. They both do a great job for us. And if an application requires something different, Jimmy will work with the client, on their specific application, take a look at what's the plan, what do we need to get done out there, and he'll make some recommendations and pick the right power section to get the job done.
Now, I don't remember if this question came in for you guys or not, but they said, cool, thanks. Do you guys sell your systems or just provide services at the well site? Are you in India? So I'll just leave this one for you guys. I think this was actually for Lane or for somebody else in the comment section, but it's a great question. I mean, are you guys doing stuff in India?
Yeah, we'd love to. I'll put it that way. We recently did a big engineering project in China to help a local manufacturer and provider of motors there improve their lower end design. So we improved their bearing mandrel. But we've got aggressive plans now that we've got our footing in the U.S. to go overseas now. Both Jimmy and I are really focused on that, and that can be in the form of rentals overseas, selling the lower ends, or doing work on other people's motors overseas to help them improve in their own applications locally.
Hold on. Oops. Nope. That's not the question I wanted. Rival Downhole Tools. Why a pin down?
Go ahead, Jimmy.
When you put the motor back into the BHA, you're no longer connecting to a bit. Most bits are pin up, so you got a box down mandrel, In this case, we're connecting to the top of an MWD system, so we put a pin down mandrel just to eliminate any additional connections.
Excellent. And then Dustin Dashell, he's over at Shell, just said, good presentation, guys. Zero bypass mud lube is a great innovation. There we go. For Rival, are you looking? Oh, here we go. We got to find out who LinkedIn user, because this is a great question. Are you looking to be able to expand into Europe and in Asia market?
Yeah, again, we really are. We're about to do an engineering project with a company over in Russia that we're really excited about. And I just mentioned the engineering project we just completed in China. So really leading with our engineering consulting services over there for motor design work, which is available in the US. If anybody has a reliability or performance issue, something they're not able to get done today, we work on that for other companies. But we intend to take our motors overseas as well in the coming year.
Well, thank you guys so much for being here. There we go. We got another one here. So Patty says, hunting motors were our go-to in Wyoming, bulletproof and reliable. So obviously that's part of the Rival fleet now. So great stuff there. Guys, thank you guys so much for being here. For everybody that is watching, what we are going to do is we are going to take some of these videos and stuff that, because I know we did have a little bit of technical difficulty as that one was playing through. We're going to take these videos when we get permission from the companies, and we'll repost these back onto LinkedIn and or YouTube, so you can see in full length the videos and stuff there. But Rival, you guys are absolutely amazing, and I have a huge debt to Neil for helping convince me to be able to do this. So please, if you guys are watching this, go check out their website, check out some of their the selection of some of the products that they sell. And like they said, they're looking to be able to move into international markets. So give them a shout. Guys, thanks for being here. I do appreciate it.
Thanks, David. Thanks, David.
All right, now we are on to, oh, my mouse is like not wanting to cooperate. Ooh, trying to slow down and enjoy it. Here we go. All right, so now it's time for our international operator panel, brought to you by Tomax. So let me move some of the stuff off of here real quick. Remove from studio. There we go. Great stuff. One less thing in here. So I'm going to try this. This is the first time we've done this. So you guys bear with me. If this works, it's going to be phenomenal. If it doesn't, we'll just go with it as normal. So this is our international operator panel, and it's so overbooked that we had to take some of the domestic operators and put them on the international operator panel, but we're just here to talk about rotary steerable stuff. So this is the time. Get your questions in, guys. Here we go. Let me see this. So we've got international op 7. So this should be the one. Oh, look, I'm on all the screens. All right, let's bring on some of our international operators, the actual international operators that we've got first. Rogerio Salo from Pan American Energy. So hello, sir.
Hello,
don't worry. We'll get everything shifted over. We've got Salib Sator from Sonatrach. All right. And where did Usama go? He's not there anymore. Oh, no. If we don't have 7 people, then the squares don't line up. All right. Then we've got Oscar Sanchez from Chevron. Oh, he's in like the worst spot possible. We've got David Pope from Ameridev. Kurt Swafford. So now we've got 6. But guess what? Oh, wait. Even if he hadn't been here, I planned for this. Booyah! Just in case. But we don't have to, because Thomas back here, and he's from Pakistan. It works! Look, I think I did it.
Yeah. It's working, right?
All right.
Yeah,
all right, guys, go around the table. Go around the table. Everybody introduce themselves. Rogerio, we'll start with you. Then Salim, Oscar, Osama, Kurt, and then David will end with you, sir.
Okay, guys. Well, I'm Rogerio. Work for Pan American Argentina. So on being the bridge with the Directional drillers company with the Pan American and involved with directional drilling projects down here. And I'm here to help with information that can lead to improvements and to future features on RSS2, mainly applicable from down here, right?
All right, Salim, you're next.
Okay, Salim Sator. I am work for Sonatrach for 20 years. So I've been in several positions, from drilling engineer to engineering manager. And we have how they say, used to work on drilling with motors, but we have introduced in Algeria the RSS. So I'm keen to introduce and to present what has been done in Algeria by the use of the RSS. Thank you.
Oscar, your turn.
Hi guys, good morning. My name is Oscar Sanchez. I work for Chevron in the US. I had a previous background, 7 years working for Halliburton, consultant and project management, and then 9 years with Chevron. In Chevron, I have been working as a drilling engineer and drilling optimization specialist for the past 9 years. I'm very happy to be here.
Thank you, sir. Usama.
Get my mic on. So, hi everyone, this is Usama, and I represent United Energy Pakistan over here. And I've been a drilling engineer for, I would say, just under a decade. So not much of an experience, but I won't discount the 9 years of experience that I have. So we uses both those mud motors and RSS, and it's an interesting topic to discuss and debate over here. I think we can move forward.
All right, hey, Kurt, your turn.
All right, hi everybody. My name is Kurt Swafford. I'm a senior drilling engineer at Oxy. Obviously, at Oxy, we have a robust domestic portfolio and also drill in a lot of different countries all over the world. And RSSs are in pretty much every well design that we drill all over the world. So we're pretty familiar with them. Specifically, I've spent the last 2 years at Oxy, and before that, I spent 7 years as a drilling engineer at BHP, drilling a variety of different U.S. shale assets during that time. And then last year, I also was our primary directional proponent, working with our vendors on root cause failure analysis and obviously rotary steerable tools. So that's why I'm here today, and I look forward to the discussion.
All right, David, finally you, sir.
Hey, good morning, David. My name is David Pope. I've been 29 years working in the oil and gas industry, providing MWD, directional, and RSS. Recently, I've gone to work for Meridev, an operator here in Austin. My title here is I'm supervisor of a remote drilling control room. Meridev's doing some pretty innovative things, doing things from remote, and that's what I got.
All right, so here's the question I want to pose to you guys first, as we're getting questions coming in from in the comments. When it comes to being able to evaluate whether you are running a rotary steerable tool versus a conventional tool, what are the methodologies that you guys use in-house within your companies to be able to make that decision? And David, we'll go ahead and start with you since you were the last one to go.
Yeah, no problem. Really, you know, it boils down to how cheaply we can get the oil out of the ground. And we have to evaluate our historic wells, and sometimes that doesn't always make sense. Historically for us, and where we're operating in the Delaware Basin, some of our more expensive and slower wells have been involving RSS. So, you know, at times it doesn't make sense for us, but there are applications obviously for it, and you know, you just can't apply it everywhere.
All right, so we'll jump down to you. We'll kind of go down, and then I don't know if we'll go left or right after that. So you guys be prepared. So how are you guys making that distinction?
So the question is for me, right? I might not hear it clearly, but yeah. So for selecting this both pieces of equipment, I noted down a couple of points that we usually discuss in our meetings. Is basically reliability, performance, and cost. So 3 things priority-wise. So we have a lot of instances where we don't think that RSS has as much as reliable tool in our environment, especially with sands that we drill over here, reaching 35 KSI in the compressive strength. So reliability is a big question. Even if it costs much, I think the tool should have the reliability to drill it as per the plan. So reliability, and then the performance. So with RSS, you still have the performance with you, but well, if you don't have the reliability, you need to pull out. And so we have seen that both of these factors come into play when we are selecting a particular tool with a particular well design, and then obviously the cost. So these are the 3 factors I would put in a priority wise. I would say these are the numbers that I usually go about. selecting a mud motor or a conventional BHU and an RSS BHU.
Thank you. All right, Oscar, over to you, sir.
For us, the evaluation of a rotor about the usage of rotary steerable tools is pretty much based on cycle time reduction and cost efficiency. Very similar to what it was described. How it was described before. So there are going to be applications. So depending on rig fleet efficiency too for flat term operations such as stripping, there's going to be maybe an advantage toward using motors. So depending on lateral length and performance differences between conventional and rotary steerable assemblies, but pretty much, it gets nailed down to cycle time reduction and cost efficiency. So very similar to how it was described before, reliability is a big part. So we tend to believe that a conventional assembly with motor tends to be more robust, so we can actually push more parameters with them sometimes. Let's say the efficiency and the reliability of rotary steerable in some areas have improved drastically, and that we have been able to put into perspective other aspects of the operation, such as hull cleaning. And sometimes the rotary steerable can allow us to have the parameters required to meet other operational objectives. So that's how we pretty much evaluate in a summary, how they evaluate the usage of rotary steerable tools.
Thank you, Oscar. All right, Salim, up to you, sir.
Yeah, the first introduction of RSS, as far as I know, in Algeria was for vertical drilling. So we had some issues in formation. So we had to we use the RSS to keep vertical in high dip formation. So, and it was a success. Then we moved for vertical kickoff in one section of some wells where we used to drill vertical to the kickoff point, pull out of hole, and run with the steerable motor. And at the beginning, we had some reliability issues because this section is high mud weight with a lot of solids in the mud. So first experience for this type of application was not successful. But with time, with the work with service company, we have done a good job. And so far, vertical kickoff was done with in several fields, and it was successful. So the last application of steerable in country is for geosteering, and in this case we have found that maybe the drilling ecosystem here in Algeria is not, how to say, well suited for RSS, because sometimes when you pick the bit from the shelf, and maybe the bit is not has not all the features to be able to build angle or to keep tangent sections and things like this, has been proven to be not successful. But meanwhile, I think that we are moving forward to see more RSS application in Algeria, and as it has been presented by the InTech lane, it's important for us to go for let's say low-cost RSS, because we are in land environment somehow similar to US land environment. So we need to go with something, let's say, less complicated and robust, but most important to be robust. Maybe by time we will see performance increase, but this is overall what I would like to say. Thank you.
All right, Salim. All right, Rogerio, over to you, sir, and then Kurt will let you round this topic out.
Okay. Well, it's pretty much a mix of everything that's already been said, and I would put on the equation the cost of lost in hole. So we actually accrue a probability of having a lost in hole and accrue on the wells, and that enters on the calculation together with the performance and the final money that we are going to be able to save.
All right, Kurt, over to you. I know you've done some pretty extensive projects on RSS evaluation, so I'm interested to hear what you have to say.
Yeah, I mean, definitely, obviously, reliability, right, is an important part everyone's been talking about. You know, that's kind of one of the things that's held back rotary steerable tools from being adopted in shale for a long time, and it's just because of bottom line cost, right? Because you've got to look at your cost of downtime as compared with conventional BHAs, which have a pretty high success rate in terms of not having a lot of failures and downtime. But when you look at the bottom line cost, you say you're drilling 60 wells in a year, and you have a highly reliable rotary steerable. Now all of a sudden that value proposition starts to tilt in favor of the rotary steerable. So especially now that we're doing a lot more directional work and intermediates now with more wells on pads, longer laterals. That's definitely come into the fold over the last few years. That's why you've seen a lot more rotary steerables sort of come into adoption, kind of like what Rival was showing. And it's just because I think it's partly because of the work that's been going on with improving the reliability and the technologies, but also just because of the way we're structuring pricing and we're able to get our well costs down and drill faster wells. The cost benefit of the rotary steerables has really tilted positively. And at Oxy, we're pretty much running exclusively rotary steerables in U.S. land. There's a couple places where we use some motors. There's a couple places where we use motors in the curves, but for the most part, we're top to bottom rotary steerables and a lot of Permian Basin stuff. And that's for a lot of reasons we're able to drill wells faster, and we're still able to impact our bottom line costs in a good way. But also there's the knock-on effects, right? Like with smoother well bores for long-term production. And looking at production wear on downhole equipment. So we've definitely seen that tilt in a positive way for rotary steerables over the last few years, and that's why I think you're starting to see a lot more of it. But yeah, bottom line reliability and bottom line cost. If you can get a reliable rotary steerable that's close to what motors are, or even remotely close, you're going to see that your bottom line costs are better, and that's gonna send it your way to send the rotary steerable in the hole.
Okay, so I've got a follow-up question there for you guys. What do you see is the future of RSS? How much do you think that it will take over as far as a complete market share? As we, because obviously we've got some great presentations today. There's more tools coming out, and there's going to be more advancements. How much more do you think the RSS? How much more do you think it can grow? Is there a point to where it will probably plateau out at? And what level of integration do you think is going to happen as far as the RSS with the rest of the bottom hole assembly and even potentially with the rig system itself? Kurt, you want to start us off?
Yeah, sure. So I don't know about plateauing. I think that's going to be kind of dependent upon, as we're able to improve the technologies, can we get the costs down and kind of what that looks like. I don't know, in U.S. shale especially, obviously, how many rigs are we going to be running in the next 3 to 5 years, and what's that market share going to look like to, keep people around to do business with us, to be honest with you. But I think in terms of, what's next for rotary steerables, I think the one thing that comes to my mind, which is a bit of a buzzword, but, automation. And when I say automation, I don't necessarily mean just integrating it into, the rig systems, right? I mean, that's one part of it, but that's like step 5. And we're really not even really to step 1 or 2 at this point. Because when you think about how we talk to the tools, how we get data from the tools, it's still kind of the way it's always been, right? So that's kind of the next phase, I think, is hopefully to where, we're able to, instead of telling the tools, hey, we want you to steer left or right, up and down this much, instead we have a directional plan loaded into the tool, and you're just telling it what depth you're at, and the tool knows what to do. So that's kind of the next, that would really, I think, kind of push things forward, because obviously, directionally, we're kind of at a point in shale where we kind of know what we're expecting. The laterals are getting longer, and we're pushing our limits. So rotary steerables almost have to be in the fold, and especially for longer laterals. But I think in general, from a technology standpoint, that automation piece and kind of being able to eventually tie that in to where, you send a tool out and it knows what to do without you having to tell it what to do is kind of the stretch goal there. And I think that, that would really improve not only the use of the technology, but the reliability, because obviously, anytime you have people trying to talk downhole to tools, there's going to be issues. You're going to be pulling out a hole for tools that aren't even broken. So kind of cutting some of those no fault found failures out is going to help a lot.
Oscar, I see you shaking your head over there. Anything you want to add to that?
No, I mean, the thing is, reliability is a big part. I mean, as tools become more reliable and more cost efficient, then there is going to be a movement I foresee to be more driven toward rotary steerables, especially as there are other considerations also put into place, such as longer laterals. So there has been a trend that for reservoir of efficiency or reservoir optimization, then there are more laterals being drilled today, and also these longer laterals are going to put a limit into how efficient actually you can do directional work towards the end of the lateral or once the lateral length increases. There is another part also that plays a big role into this, and is wellbore quality. There has been a big discussion nowadays about wellbore quality. Comes into place with inclination and azimuthal hole, right? So the straighter we can drill a wellbore, or the less tortuous we can drill a wellbore, then it's going to bring other aspects of efficiency. So in cycle time, such as casing running operations and tripping out of the hole, right? So the rotary steerable market will have a bigger advantage in comparison with conventional assemblies when we put all these variables into place, right? So the technology is advancing. We'll see new rotary steerables coming in the market with improved inclination and azimuthal hole, and as all these variables are put into place to compare the efficiency or not of rotary steerable system, I mean, I would foresee that the rotary steerable market will continue increasing.
Excellent. Well, so I'm down to you. So Oscar was talking about, as far as the wellbore quality, is that one of the deciding factors that you guys have within your organization when, selecting tools?
So selecting tools, obviously, basically wellbore quality does come in play. Obviously, it's over the period of time, it's getting bigger and bigger, this factor in. So obviously, our experience comes from what we have drilled in the past. So where we work, we are one of the biggest E&P companies in Pakistan, especially drilling in the south of Pakistan. The wells are not, the challenge over here is now, these are not offshore wells, these are not high-cost wells, these are low-cost wells, under $5 million, let's say, and then I need capital efficiency for this tool to run continuously. So I was, during this discussion, I was remembering in my mind that if we are capable to run a well or a tool for 3 wells, and then we have reliability problems, or let's say a lost in hole, so that the cost efficiency from all of these wells is going down on that 4th well. So this all comes into play, I think, and it's an important factor that how costly in the overall life cycle the tool is, basically overall the life cycle, how expensive the tool is. So for me, it's a big factor while selecting a tool.
Excellent. All right, Rogerio, up to you, sir. What do you see as far as the future of the RSS market in South America?
Yeah, well, a part of the automation that Kurt has been said, and something that's already touching the door, right? So it's already to happen. It's going on right now. So I do see adaptive filtering or intelligence or artificial intelligence to take decision. For example, let me give you an example. If you hand off formation that really high drops you into a side, and your algorithm it's already to keep the azimuth already deviated, right? So in the future, I see that the tool is going to take the decision and communicate the directional driller to see. I see a better pattern on the trajectory from now on, from where I am right now, and the entire system is going to adapt the trajectory and the force on the pads to adjust better, to have a holding, not just holding as with an inclination, but adjusting back for the trajectory. and lots of efforts on machine learning to take better decision and leave the directional driller to take the decision on improved performance. Right now we have a directional drilling try to follow the path and improve the performance. And we know that there is no multi-function people, right? So not even compare those multi-function to function at the same time. What they do it's switching from function to function, and by removing multi-function from one person, we are going to see more effort concentrate on performance. So we are going to see more drilling performance rather than try to control the well pattern, And what do see more, and also do see some improvement on reliability on the near future with improving on electronic technology, even the mass of the sensors. That's something else that's touching the right now that we have right now for implementing. And with that, and together with better hydraulics and better dumping on the shock inside the tool, which is something that InTech presented for us, but I see even in a higher level of the future. So we are going to be probably face more robust tool and more adaptive tools on the future. So no failure, just focus on performance.
All right, so I got a question. I'm going to bring this question in for David and Salim. It says, push the bit versus point the bit. Any preference in offshore or land? So Salim, do you want to? I know that you guys are just doing vertical applications, but does it make a difference to you guys?
I mean, let's talk maybe for the land drilling. Do you hear me?
Yeah, go ahead. Sorry.
Yeah,
Usama just dropped off.
Drilling, for land drilling, it is really important. I mean, one of the points that has been highlighted is the relatively low cost, because DrillX is relatively lower than offshore environment. So, but what we would like to see is any technology that would bring us, I mean, let's say, relatively lower cost, either push the bit or point the bit would be welcome. But here, so far, what is the element that is not, how do I say, enabling this RSS to be gaining market share is the price. The price and the lost in oil. The price, the day rate, I mean, the secreting hour rate and the lost in oil. So that's the reason so far in our market. I mean, the RSS is not competitive regarding the conventional, how do I say, directional modes of PDM and things like this. But from our experience, all our experience in Algeria were with push the bit, and we achieved all what we have done. But even though, I mean, I would say is we are not pushing the drilling to its limit. We are not reaching the boundaries that has been reached in US land. So maybe in the future, because you know, all what has been achieved in US will give us an insight, because maybe in the future, planning and drilling very raw materials would be something that would be considered by our subsurface department. So something we can talk about it and think about it and plan it for the future. So, but I would say both technologies would be considered. Thank you.
Excellent. And David?
Historically, your point-to-bit systems are better suited for softer formations, and your push-to-bit systems are kind of applicable in the Delaware Basin or harder rocks. But both systems are obviously making big leaps and bounds in their reliability and durability. And, you know, I think, you know, future is definitely trending towards RSS. I don't know that it's going to get there 100%, but anyway, hope that answers that.
Well, what do you think as far as like, how much market integration do you think the RSS systems would be able to make?
I mean, it's obviously growing, and I mean, I think it's going to be easily 40% at some point. I don't think 50%, maybe not in the next 20 years.
So now this is one of the really important questions I had, since I wanted to be able to have you on this panel, and I wanted to be able to ask you this one. Going from having been on the service side and then now recently moving over to the operator side, what advice do you have for those out there that have never been able to be on the operator side, and give us a kind of idea of what that transition's been like for you?
Right. On the service side, we were really looking at records, setting the fastest records, shortest lateral times, and, proving our service. That's what sells things, gets people interested, gets engineers talking about it. And, that's really was our prime focus. Now on the operator side, there's a lot of intangibles and things you got to consider. And, there's a lot more to the equation than just the fastest well. Like everybody's on this panel said, reliability and durability and number of runs, rebuild charges, lost in hole, all those things factor in. And, you got to get it done for the cheapest price at the end of the day. So there's definitely a lot more considered.
So going on that reliability, Rogerio, we'll start with you, sir. What do you want to see from the service companies or the technology providers in terms of reliability to be able to give you that warm and fuzzy feeling that their tool is going to be able to perform at the level they say it?
Well, it's simple, right? So we have some wells, so we put some tools, and we expect them to have a low failure rate. So for example, in here, we have just two kind of applications. We can go in the lateral, or we can build a curve and do it shoe to shoe. The desire of doing shoe to shoe it's for everyone, but we know that we have a piece of formation, very hard, very, very high vibration, and reduce the lifetime of the tool very, very for a lower level. So we do have MTBF with by doing just lateral, and another one really different by doing this curve. So we want to do this curve, but sometimes when you make the math, it not work. So we need tool that does not fail, that can handle this kind of environment and does not fail statistically, right? So you can have one failure each time, but not every often. So at the end of the day, David said the tangible things, the equation is gonna say if it goes or not. You can have a failure, but just amount that fits into our equation. Otherwise, there is no reason to use a rotary steerable.
All right, and Kurt, for you, I wanted to ask you the same question as far as what you were looking for from companies to be able to give you, since you guys said y'all are almost exclusively rotary steerable. What are you looking for from those technology providers to give you that confidence that you're getting a good, reliable tool?
Yeah, so I think in terms of, obviously we've talked about the failure rates and trying to minimize that as much as possible, but also it comes down to how a service provider runs their business from a standpoint of quality, right? Because there's a feedback loop, right, between operators and service companies where, we're using tools, we're running them in specific environments, we're running them with specific parameters, and we're having failures, and obviously with rotary steerables, they're more susceptible, they're just more moving parts, they're more complex tools. So there needs to be a really solid feedback loop where we're having failures, we're getting investigations done in a timely manner, we're understanding why tools are failing so that we can implement changes and try to eliminate root causes. So, I mean, that's something where, you can look at the tools and the technology as part of it, right? And the run data and reliability is part of it. But also it's about, okay, when we're working together, how are we going to make sure that we're always improving that benchmark of success? Because our expectation is when we run a tool in the hole, it's going to complete its task and it's going to achieve its directional objectives. And, that's the entire proposition for rotary steerables, right? It has to be able to do those things. So if it's not able to do those things, let's figure out why it wasn't able to and what we're doing wrong, or what, maybe from a design standpoint can be changed, and how quickly we can do all that is really important.
Well, guys, thank y'all so much. It's time to move on to the next portion. I really do appreciate all of you guys being a part of this. It was absolutely amazing. Even Oscar, Salim, saw David, Kurt, and Rogerio. It's been an absolute pleasure to have you guys on this panel and continue watching. We've got a lot more great presentations coming up. All right, guys, moving on to the next spot. Let me go ahead and get all of the everybody off here. Boop, 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 boop. All right, I think we did it. Oh wait, nope, there's still Oscar. All right, bye, Oscar. All right. On to the next set of presentations. Guys, hey, please share this. Please let other people know. We're trying to break 1,000. We didn't do it. We're not there yet. We're still coming up to the normal hours of operating business here in the US. So I think we'll probably get a pretty good group of people coming in. So here's your next presentation. These are the first guys to be able to sign up for the event. Here is a presentation from Kinetic Upstream.
Wow, that's amazing, isn't it? That doesn't get old, does it? Well, that's just the latest accomplishment from NASA. That's the Perseverance Mars landing last month, February 18th. They actually landed on Mars using automation, and it's amazing engineering. They build on past missions. You know, NASA does that. They stand on the shoulder of giants, but they use something new this time. They called it terrain relative navigation. Terrain net relative navigation actually uses sensors. It uses computing power to automate landings. And Jeff, you actually worked on, I think it was the Mars Pathfinder.
Yeah, I did. Yeah, I was lucky enough back in the 90s to work on the Mars Pathfinder entry, descent, and landing team. And back then, we didn't have a controlled landing. We actually used big balloons to bounce down on the planet. And the little 25-pound rover that we had actually had the capability to do autonomous navigation, and that was with a computer 400 times less powerful than the one in our RSS now.
Well, we've been utilizing terrain relative navigation for years in the oil field. It's called geosteering.
That's true.
We've been doing that, but you know what? There are similarities a lot between space landings and landing horizontal wells.
Yeah, they're both a horizontal, both a hostile environment, certainly.
Yeah, GPS doesn't function. Doesn't function in the Mars atmosphere, and it doesn't function underground. So we have similar challenges there. And ellipse of uncertainties is also a major challenge for us, both in the oil field and landing wells, and in deep space. In deep space, it's on the order of miles, and in the oil field, it's on the order of feet, hundreds of feet. But both have similar challenges for similar reasons.
Yeah, one big issue is real-time decision making. NASA has to overcome 120 million miles, and as you saw, a 20-minute communication delay, and we just have to overcome mud pulse telemetry.
That's a tough, tall order, as we know. It was interesting though that on the Apollo mission, they actually had to use visual flight referencing to do that last descent. But this terrain relative navigation that NASA uses now, and really used it on Mars the first time, was a truly automated landing. The Perseverance took over control and landed on Mars.
Yeah, well, at the time of the Apollo mission, the human brain, specifically Neil Armstrong's brain, was just the right stuff for that. So, I'm really proud of our team and our technology. That in order to create a next generation rotary steering system at a fraction of the cost, we had to have experience, right? And so we ran the numbers, and I ran the numbers the other day. We have 244 years of industry experience on our team. 138 of those are RSS, and that's just 12 people.
Yes,
So-
Harold. But we also have good financial partners, and we have good technical partners outside of the company. We know what we don't know, and we go to great lengths to find it. And we've got a great team both inside the company and with our partners.
So I'm going to show you where in the slide here, I'm going to show you where we are right now. We've got, 40 years ago, we decided to really focus our course on automatic, geometric, and geological steering. So I've got a timer here. Thank you. We needed an RSS. In order to do an RSS, we needed rugged, universal, and proportionate steering. And so that's where we are today. This is what we have. You'll see more about that. And then, of course, February 2020 happened.
Well, February 2020, we had our first commercial run, and it was all good.
Yeah, so you all know about that, and we're very sympathetic to everyone for what happened in 2020. Right now, we're refining our technology, and by the way, we had a little bit of revenue in 2020, so we're still going. But again, thanks, David, for making this possible. Thanks for everybody viewing this, and here's a short presentation to learn more about our products.
Thank you.
Thanks.
Well, thank you, Jeff, and thank you all for participating in this virtual event. It is indeed my honor and pleasure to be able to present to you Kinetic Upstream technologies and some of the products we're currently commercializing. Kinetic Upstream brings a unique patented design of automated rotary steering system to market for improved directional and horizontal wellbore placement. The Contour is our flagship product, an automated steering system that is simple and robust, yet technologically advanced in steering control and downhole measurements technology. Kinetic has also developed and deploys the K-pivot stabilization technology, which dampens harmful drill string vibration and improves steering control with both rotary steerable and conventional steerable motor BHAs. Kinetic BHAs are smart. We have developed what we call the DrillCom sub and the Connect downhole communications network. The Connect network allows for robust, flexible, two-way communications and control systems that are compatible with most MWD telemetry systems on the market. This allows for customers to utilize their existing MWD assets in conjunction with the Contour. Kinetic Contour improves geometric and geological steering control and ultimately delivers more productive well placement. At Kinetic, our vast downhole tool deployment operational experience reminds us that slow is smooth and smooth is fast. Ultimately, well placement is a real-time event where execution matters. Ensuring a smooth wellbore is paramount to ensuring a smooth operation. And a smooth operation ensures the lowest cost per BOE produced. Longer laterals, smoother, less tortuous wellbores are more productive wells and faster to execute. Common rotary steering systems, such as the power drive on the left in blue and the auto track system in the center in yellow, and their numerous copies thereof, are capable technologies, but they utilize external fast-moving pistons or paddles to maintain a side force in a preferred direction. The speed and consistency or inconsistency of rotation raises the duty cycle of these highly dynamic systems. The Kinetic Contour system on the right decouples its rotating drill string from its steering housing, slowing the duty cycle required on the system. This improves reliability and steerability. Many of these competitor tools require rig system hydraulic pressure to generate the pad force, making performance suffer on the deeper, more challenging wells, or any well where hydraulics limitations may exist. High duty cycles and the geometric and side force limitations of some competitive systems are prone to hole ledging and ultimately higher wellbore micro tortuosity. The slower rotation of the contour steering mechanism enables the four-dimensional control of an internal offset within the tool, not paddles or pistons. The offset can generate large bit deflections and side forces in precise proportion to what is precisely required to achieve the directional plan. Slow is smooth, and smooth is fast. Excessive or unplanned tortuosity leads to problems with drilling, completion, and production of wells. It is important to monitor, measure, and understand this micro-tortuosity and its effect on well performance. Micro-tortuosity may be defined as a higher unmeasured or unobserved tortuosity with respect to measured or planned. Thus, the true tortuosity of a well path is underestimated. The true vertical depth of the well is inaccurate, and the risk of successful drilling, completion, and production is decreased, and the ultimate cost of a well is increased. Micro-tortuosity hides the cause of many drilling, completion, and production problems. Excessive torque and drag, hole cleaning, weight on bit transfer, difficult steering, stuck pipe, poor cementation, non-optimal completions, inaccurate well placement, tubing casing wear, and non-optimal fluid flow all may be the result or misdiagnosed due to micro-tortuosity. Kinetic Contour Automated Steering System is simplicity in action. The tool is a robust integration of a very few components, but a leader in capability. A powerful electromechanical system controls two internal sleeves, which control tool face and dogleg on demand, or through automated self-steering control. Four main components assemble to provide the tool's framework. A mandrel runs through the center of the tool and is attached to the bit, transmitting all rotation, torque, weight on bit, and flow required to drill. An outer housing is stabilized to center the tool within the hole and provide lever points to generate bit side force. The red sleeve is actuated by a brushless DC motor and moves a lower mud lubricated bearing up and down around steering head seen in blue. The cross section in the upper right through the blade housing, you can see that the tool is now positioned in a build or high side position by levering off the low side of the housing. The blue sleeve is actuated by a second brushless DC motor when we want to rotate the tool face and when it's required to maintain good directional control. Fewer components enhances reliability and improves running cost of the system. The precise independent tool face and dogleg control ensures smooth transition of well geometry and minimizes micro-tortuosity. K-pivot stabilization is placed at the top of the contour, decouples bending from above the steering head, improving directional control, ensuring smooth tripping and drilling. We're very excited about our K-pivot stabilization technology, which provides drillers a tool to improve ROP, reduce non-productive time, and facilitate more efficient well placement. The K-pivot system improves the drilling trajectory through more consistent and precise control of the bit steering forces. The K-pivot also enables faster, trouble-free tripping. The K-pivot solution allows drill string vibrations to be absorbed, isolated, and decoupled from lower BHA steering components, helping to center and stabilize the bit, which results in improved ROP and longer bit life. Vibration absorption, isolation, and decoupling also reduces mud motor, rotary steering system, and MLWD component damage, reducing non-productive time that occurs with shock-induced BHA failure. Robust two-way communication system is another feature that sets the Contour apart from most other systems. The ability to quickly and reliably communicate to and from the downhole bottom hole assembly is critical for good directional control. The Contour rotary steerable system deploys onboard directional and other sensors, as well as power, electronics, motors, and motor controllers. Contour is also equipped with transceivers, enabling wireless communications capability to and from MWD systems. Thus, when running in bottom hole assemblies with mud motors, the MWD can be run above or below the mud motor. This also improves reliability of the system, as hard connectors are often sources of failure in other systems. Downlinks can be achieved through simple RPM commanding or EM-MWD transmission. Uplinking can be achieved through a variety of EM and mud pulse MWD systems. Customers are able to use their own mud motors and MWD systems in conjunction with the Contour. Critical downhole information uplinked in real time improves well placement, service quality, and drilling efficiency. What are the advantages of the Contour over the existing designs of rotary steerables? The Contour is the next generation of rotary steering. Simpler, but purpose-made for today's service-intensive, unconventional plays. The sculpted tool housing allows for maximizing flow area for better cuttings removal and smoother tripping. Contour is high dogleg capable, enabling vertical, curve, and lateral intervals to be accomplished on one run with one bottom hole assembly. The non-magnetic design allows for use of high accuracy onboard directional sensors for precise wellbore control and flexible wellbore designs. The simplicity of the technology also is demonstrated through its ease of use and high rig efficiency. Unlike other tools, Contour does not rely on rig system hydraulic power to generate a bit side force. Thus, the Contour has no practical limit on flow rate, and the rig can utilize valuable hydraulic power for bit and hole cleaning. Contour also has no practical limit on rotary speed for faster rates of penetration and elimination of many tool performance issues competitor tools see when encountering stick slip torsional vibrations during drilling. Inclination and azimuth are also located 7 foot from the bit face with the Contour. This improves our ability to place well bores and to utilize automation for precise wellbore placement. Contour has been built upon a reliable tool platform. It comes from a pedigree downhole tool design, which means proven simplicity and early reliability. The RSS boasts less than 300 total components, engineered for field serviceability, which means the Contour can be serviced in a standard motor shop. This translates to low capital and low maintenance cost, ensuring delivery of a value-driven solution for well placement. The K-pivot technology dampens vibrations and reduces internal tool stresses, improving directional control. And the Contour is designed to run with both uphole and downhole communications, utilizing a variety of MWD systems, meaning customers can source and select their preferred mud motor or MWD system of choice to run in conjunction with the Contour. And Kinetic is on the drive to the future with automated geometric and geological steering and manless operations. At Kinetic, we see automation as a continuous improvement process, but we're building on our existing Inc and as hold features and our cruise capabilities. A robust hardware platform is already in place to facilitate rapid implementation of firmware software enhancements. Downlink capabilities and onboard navigational sensors allow for automated coordinate or geometric steering protocol, enabling the fastest, most accurate steering possible. Multiple continuous navigational sensors placed along the BHA are enablers for automation and downhole positioning and survey quality control and management. The Contour system was successfully trialed in multiple wells within the United States, within Colorado, Oklahoma, and Pennsylvania in 2020. Kinetic overcame the logistical challenges of the global plague and oil price collapse, but were able to validate Contour technology and manufacture for early deployment to customers. Data was acquired to support and improve the technology, but Contour has already proven capable. Among the achievements include a demonstrated one-run, one BHA vertical curve lateral capability, excellent trippability of the BHAs in all wells, 97% or greater reliability on all on-bottom two-way communications, demonstrated high dogleg capabilities up to 17 degrees per 100, approved robustness of the design, and demonstrated good or better than competitor performance in geologically challenged water-based mud environments. Contour, K-Pivot, and DrillCom Connect technologies combine now to move us down the road and closer to realizing our kinetic vision. Our technology roadmap continues in 2021 with automated geometric steering, and then on in 2022 with automated geological steering and downhole survey quality control and survey management, all leading us to manless directional drilling. Thank you for watching. Please reach out to us if you have questions at www.kineticupstream.com. And remember, Kinetic is unconventional innovation.
All right, Kinetic guys, thanks for that amazing presentation. On to our next one so we can catch up. Here we go. This is from the guys over at Sparrow.
Morning, everybody. My name's David Kramer. I'm the president at Sparrow Downhole Tools up here in Calgary, Canada. We at Sparrow look at rotary steerable from a different angle. We make slim hole rotary steerable tools. Now, why slim? It's because we are founded on the values of simplicity and reliability and affordability, and we find that slim hole matches those values very well. Let me start with the basics of our tool so that you know what we're dealing with. The Boxer rotary steerable tool is a push the bit, constantly rotating style of tool, using mud-powered pistons to apply side force to the wellbore. We have one single valve operating the pistons, and everything is strapped in so that it rotates along with the BHA. The tool is good for 350 RPM, and we accept downlinks, and we do send some uplinks so that the operator knows that the tool is playing by the rules. Now, let me tell you what we're doing a little bit differently. First thing is that our tool can be assembled on site. So in the same way that you would take an MWD tool and assemble it and then install it into a mule shoe, we can assemble the modules of this tool, program them, and install them into the bias unit. You can do the assembly in the shop if you want, but for anybody who's looking for the flexibility and the affordability of field installation, now you got it. The other thing differently that we're doing is battery power. Our tool is efficient enough that we can run with batteries as an alternative to an alternator. 2 battery sticks will last our tool 6 days. And the third thing, like I said before, is small size. We saw an untapped market in directional control for slim hole. And knowing that it's easier to start with a small size tool and then design it bigger, we set ourselves the goal of a 3.5-inch tool first. Now we have a tool that's capable of drilling 3 7/8 inch wellbore, which we believe to be currently the smallest one available in the world. In terms of downhole time, our most recent experience is milling casing windows. Now, milling casing windows with a rotary steerable isn't typical, and it's a pretty specific application, but it turns out that it can be done. And what we've learned is that in order to not have your assembly hang up as you're coming through the window that you've just milled, you need to have a bias unit that's about 1/2 inch under gauge from your lead mill. And what that means is that you need to have a piston stroke of about 5/8 of an inch in order to do any meaningful steering. And this is, we learned this over a couple of attempts, but we did it to prove that our tool was going to be as reliable as we thought that it should be. Milling means a ton of vibe, stick slip, shock, and I'm proud to say that in 5 runs we haven't had a failure yet. The reason that our tool is as reliable as it's proving to be is that because of the design, we're able to use every trick in the book that we know from our time designing MWD tools. Also, we are absolutely relentless when it comes to cutting component count. I've been in the rotary steerable game for 20 years or so. Our team is cut from the same cloth. And we are all 100% dedicated to building 100% reliable tools. The way we talk about it is that we say everything that we build has to work in a frying pan on a jackhammer. That's the mindset that guides everything that we do here. When we started this, we imagined a rotary steerable that was capable of doing completions and well extensions in wells that had existing 4.5-inch casing installed. Now we can go further. Imagine bringing that rotary steerable tool out to location in the back of a pickup truck. Imagine drilling with coil. When you're done the well, imagine taking the tool home in the same pickup truck and turning it around in a day so that you can go out and do it again. We are trying to do things differently. We know that people are looking for stability and affordability. Our vision is to build the simplest and smallest rotary steerable tool in the world. And if that tool can help you achieve your vision, then please give us a call. All right, thanks for listening, everybody. Appreciate your time, and back to you, David.
Is it off? Oh, there we go. Oh, slight technical difficulties there, trying to be able to get everything removed. All right, so up next, you guys, we have got Josh Wilson with Scientific. Let me move this. Add Josh in. Josh, take it away, sir.
Thanks, David. Appreciate the opportunity. Excited to be here. Good morning from Houston. My name is Josh Wilson. I manage the Operations Engineering and Product Support Group. I am also the operations lead for our Halo rotary steerable system. So I wanted to take this quick minute to get you a little more familiar with our system and where we're at today with it. So when we set out to design the tool several years ago, the main focus was 3 areas: directional control, performance drilling, and somewhat of a simplistic plug and play operation, which That's what led us to our fully integrated system that we have. So the only thing we have to do at the rig side is plug in, pick it up, run in whole, because we've combined the steering unit and the MWD into one tool and it gets shipped to the rig that way. So we're not having to fumble around with making up connections on the rig floor or trying to connect to different components, and it moves all our measurements that much more closer to the bit. We have built-in automated directional control with near bit inclination and near bit azimuth sensors. So we tell the tool an inclination and an azimuth. The tool will drill to and maintain those directions automatically. We've seen very robust performance out of that over the past several years. And that actually enables us to better optimize our BHAs for those one-run vertical curve lateral applications. It allows us to get away from those overly stiff BHAs where maybe we include certain collars or things to keep that BHA on track. These algorithms negate that need and allow you more freedom in your BHA planning. In terms of dogleg capability, the 6.5-inch tool is rated for 15 degree per 100. The 5-inch tool is rated for 13 degree per 100. And those are really max operating points. So from a well planning perspective, you're looking at going with a 10 degree per 100 for the 6.5-inch or 12 degree per 100 for the 6.5-inch or a 10 degree per 100 for the 5-inch. It is a push to bit system with self-contained hydraulic units, so we don't require additional pressure drop through the tool to operate the steering mechanism. Obviously, that becomes beneficial in pressure-limited applications. We are bit and motor independent, so we don't require any specific manufacturer or model of these components to be successful. We certainly have a preference to run our motors, and that's more to have a little bit more control over the quality of the tools that are going in whole. But we have many documented cases of success with third-party tools. Same thing with bits. We're not tied to anyone in particular, any one design. Just with our experience, we know that certain features are better than others in certain applications. So all that we ask is that we're involved in that conversation so that we can get everybody on the same page as we go forward and plan for success there. A bit more on the technical side of things. So the 6.5-inch tool intended for 7 7/8 through 9 7/8 inch hole, while the slim hole tool is for 5 7/8 to 6 3/4 inch. And the only thing that really changes between those hole size variations are the stabilizer dimensions. Everything else in the tool remains the same. And the benefit to that is it's always relative to the hole size, so you don't lose any build rate potential depending on hole size. Sensor offsets, so the near bit inclination and near bit azimuth, again, that feeds into the directional control algorithms. Between 5 and 6 feet behind the bit, and the exact location depends on the tool size. And that's, so the internal workings of the tool are identical between the two tool sizes. It's just slightly different in terms of exact layout, just because the housing is different. Obviously, it's a different tool size. And then annular pressure, if PWD or monitoring ECD is something that interests you, something that you need to be successful, that's certainly a service we can provide with those sensors being a couple feet behind the bit. And then, of course, gamma ray, azimuthal or bulk in real time. That becomes very beneficial in geosteering applications, which we do on a fairly regular basis with a lot of success there. In terms of downlink, we are a flow-based system, so we modulate the pumps on the surface to talk down to the tool. The mud pulse system built into the tool communicates to surface and provides that continuous two-way communication that allows us to downlink and receive information back while we're drilling ahead in both scenarios, which of course adds to our efficiency. That's really it in a nutshell. Just kind of wanted to throw some 2020 numbers up there. Just, you know, everybody knows 2020 was a bad year for everybody, but to be able to get out there and perform and get some footage under our feet, I think says a lot about the tool. So 4,600 circulating hours, just under 660,000 feet drilled, with our longest run pushing the 3 miles mark. That was a one run, very good success there, with key operations in the Permian, Mid-Con, Rockies in the Northeast. And 2021 is looking to continue that success forward. And that's really all I got. So if you got any questions, shoot me an email. Find me on LinkedIn. Let's connect and talk about what we can do. Appreciate it.
Josh, thank you so much. And thank you, Scientific, for being a part of today's event. And we're on to our next one. Next up,
we have got Scout.
Good morning, everyone. My name is Steve Jones, and I am the President and CEO with Sambian Technologies. Today, I'm going to present Rotary Steerable Scout, the low-cost rotary steerable technology for land-based drilling operations. This is going to be fast, so please watch closely. First off, we will start with the engineering team, as they are an important aspect of the RSS development program. The engineering team on the Sanvian side came from Pathfinder Energy Services. They were responsible for the development and commercialization of PathMaker RSS that was purchased from 3D Stabilizers in Aberdeen back in 2002. Pathfinder was then purchased by Smith International in 2009, and by that time all sizes of PathMaker RSS were deployed globally. We were then acquired by Schlumberger in 2010, and the rest is history. The engineering team then looked for the next target project. We came across the Vertical Scout from TurboDrill Industries, a pure mechanical vertical drilling tool. We formed a partnership with TurboDrill Industries in 2015 and commenced the development of Rotary Steerable Scout. Now we consist of the mechanical engineering team from TurboDrill Industries and the electrical, electronics and control systems team at Sanvian Technologies. So why use the mechanical vertical Scout as the platform for an RSS? Well, there were business advantages and there were technical advantages. On the business side, we could use existing TDI mechanical assets, and that resulted in lower development costs, lower commercialization costs, and these lower costs could roll down to our customers. The Vertical Scout is a known and proven product, so it was easier to find test partners and easier to test on live wells. On the technical side, mechanical reliability was already established. The mechanical tool had drilled over 6 million feet. It was a fully mud-operated push-the-bit system, and all hole sizes of Vertical Scout were available from 5 7/8 to 24 inch. So here's how it played out. We started with the mechanical Vertical Scout. We removed the mechanical pendulum and valve, and then we transplanted the electronic control unit and digital mud valve into the tool. We also have all steering pads on the same plane for 8.5 and slim hole sizes. This is truly an industry first. The digital mud valve is the heart of the system. We require 500 to 600 psi below the tool, and the digital mud valve is used to control the steer and grip forces supplied to the pads. An accelerometer senses pad 1 gravity tool face. A magnetometer senses pad 1 magnetic tool face. This allows us to steer on magnetic tool face at low inclination and gravity tool face when above 3 degrees. A motor positions the digital mud valve. Only 10% of flow is diverted through the digital mud valve. This video shows the operation of the valve as the slow rotating housing rolls. The pads are removed to give a good visualization of the flow, and the tool is set up to steer low side. You will see the majority of flow coming from the upper pad. This is steer force. There is less flow from the other pads as this is grip force. As we roll the slow rotating housing, you will see the steer force flow transition to the 2 pads to maintain tool face. This continues as the housing rolls to maintain the required tool face. This valve is truly simplicity in action. To lower our operating costs, we use Rotary Steerable Scout with our IntelliScout Smart Motor. This allows us to run only the RSS below the motor. The IntelliScout motor provides real-time near-bit inclination directly above the RSS. We can also detect RSS downlinks at the IntelliScout and MWD for real-time downlink confirmation. With only RSS below the motor, this removes the need for HFTO isolation tools, which significantly reduces our operating costs. This is a much simpler BHA with less equipment below the motor. So this also reduces our risk of damages to equipment, a simple and effective method to lower the cost of operation to our customers. And finally, to conclude, our specifications are on the table for reference. Rotary Steerable Scout is a fully mud-operated push-the-bit system with slow rotating steering housing. It's built for vertical nudge, tangent, and lateral applications. We have closed loop hold inclination and hold inclination azimuth. We have simple and reliable on-bottom rotary downlinks. Our electronics are isolated from HFTO because the steering housing is decoupled from the drive mandrel. The low-cost RSS solution has arrived. I would like to take this opportunity to thank our West Texas customers for the testing opportunities to advance this product. I'd like to thank you all for your time today, and thanks to David Gibson for arranging this event.
Yeah, I made a mistake there, guys. Sorry, my mic was on. Trying to do some stuff behind the scenes. Sorry, my bad. All right, next up on the bill here, you might have seen a viral video about a rotary steerable tool. Actually, don't call it a rotary steerable tool. This is the guys from CT Energy Service. Andre, take it away, sir.
Hello, hi, good morning, David, and it's great to be here. It's great to everyone here on the Gibson's Rotary Steerable Live event. Good morning. Thank you for having us. Andre Sampson, Global Business Development Manager for CT Energy Services here in Houston. You know what, when we first introduced the Hydroclutch, some of the initial responses we receive are that it's alien, novel, or as you said a few weeks ago on LinkedIn, black magic with hashtag game changer. Our industry defines a rotary steerable system as a tool designed to drill directionally with continuous rotation from surface, eliminating the need to slide the mud motor. And that is exactly what the Hydroclutch is. Re-engineered, repurposed, 30-year-old drilling motor technology. It's just upside down, conventionally speaking. Josh up in Calgary, our chief engineer, take it away.
Hello, I'm Josh Campbell, the chief engineer here at CT Energy. Thank you for the time and opportunity to discuss our Hydroclutch tool. It's been generating some buzz from that recent video on social media. Today, I'll make sure to get into the premise of the tool, explain how we do it, follow up some additional benefits, as well as hopefully get to some commonly asked questions. So the Hydroclutch. Basically, the Hydroclutch is a purely mechanical tool that goes about 200 to 300 feet back from the bit, and it allows the operator to continuously rotate the pipe at the same time slide the BHA, controlling direction left and right by balancing string RPM with motor differential. The way we do this, in essence, is we take a drilling motor, we flip it upside down, and we screw the drill string into the bit box. We then take what we call a pressure sub, and we turn that motor into a pump. So when you're not rotating the drill string, you're not developing any torque in our tool. And through drill string rotation, we develop hydraulic torque. And we then use that hydraulic torque to control or overcome the reactive torque of the downstream drilling motor. By manipulating surface string RPM and motor differential at target parameters, we're able to balance the reactive torque of the drilling motor with the torque developed by the Hydroclutch. When those two are balanced, the BHA is sliding with continuous string rotation above the tool. And when they're unbalanced, you're rotating ahead. During a slide, if you want to move left, you can either decrease the torque in the Hydroclutch by reducing string RPM or increase motor differential. Either way, the reactive torque in the drilling motor will be slightly more than the Hydroclutch, and you'll slowly move tool face to the left. If you want to go right, do the opposite. Increase the torque in the Hydroclutch through increasing string rotation or decreasing motor differential. This way, the Hydroclutch will generate slightly more torque than the downstream drilling motor and slowly drive the BHA to the right. To enter or exit a slide, you don't have to come off bottom. To enter a slide, you just have to dial back string RPM and your motor differential to targets provided, and you'll be balancing the two torques. Something really important to note here is there is no clutch mechanism. You're never engaged or disengaged. It's just a matter of balancing two torques that are generated in two different ways. The drilling motor, conventionally with flow and differential pressure, and the Hydroclutch with string RPM. So you can perform sliding or rotating head operations to a large range of drilling parameters. To exit a slide, all you have to do is bring your drill string RPM back up to rotating head parameters, whether it be 60, 80, or 120 RPM, and then bring up your weight on bit to build motor differential to whatever your rotating head parameters are at 500 or 1000 PSI. Using off-the-shelf components, it's an oil lubricated bearing pack, a standard power section, and a few mechanical components in the pressure sub. We're able to achieve continuous string rotation with proven conventional technologies. Some of the key benefits that we have here is there's a significant increase in sliding ROP when you compare to conventional. Typically, we see over 50% increasing in sliding ROP. Bit on bottom time is typically increased by 5 to 15%. Providing conventional motor build rates, the Hydroclutch is a significantly lower risk and lower cost alternative to typical rotary steerable options. I'm sure I've raised a few questions here, so do feel free to get in touch with us through our website or LinkedIn. I'll review some commonly asked questions here before I pass it back to Andre. The first of those questions is, what is the average increase in sliding ROP and slide efficiency? And like I said, 50% sliding ROP increase. But as you get out into those extended reach applications, we do see more, closer to 100% increase in sliding ROP. Our sliding efficiency, we typically improve by about 75% when you kind of account for all the sliding operations that are required to perform a conventional slide. We take about 75% less time to drill a foot. How does the Hydroclutch integrate with directional drilling services? We can operate with any directional drilling services team or MWD equipment. There's no restrictions for our tool. Where in the well has the Hydroclutch been run? We typically operate in extended reach applications, but we have landed multiple wells from 60 out to 90, as well as kicked off from vertical out to a 15-degree tangent. So that's all the time I have now for questions. I'm going to give it back to Andre to discuss an exciting deep dive we're going to be doing on our tool in the near future. Thank you for your time.
Yes, thanks, Josh. And just want to take the opportunity again to thank Gibson's Rotary Steerable Live event. But in April, please go to our LinkedIn page and sign up for our own live event where we will do a deeper dive into the tool. We'll show it in the shop. There'll be more run data and showcase more of the benefits that that are provided with the Hydroclutch. Thank you.
And thank you guys for being here. Do appreciate y'all being a part of it, and can't wait to see the response you guys get from the community out there. All right, guys, rolling right along with us. All right, so that was CT Energy Services. Next up, we've got Schlumberger. They've got a quick little presentation that we'll show you, and then we'll be doing some Q&A with them right after the video. Here we go. And I'll turn my mic off this time, I promise.
Thanks all for joining us today. We will here discuss Schlumberger's new generation of push-to-bit rotary steerable system, the PowerDrive Orbit G2. And specifically how this new technology applies to the US drilling market. So first, where does PowerDrive Orbit G2 comes from? In Schlumberger, we have a vast base of rotary steerable systems operations. With all our RSSs, which we have been developing and using in the field for more than 20 years, we have accumulated a massive amount of experience. And PowerDrive Orbit specifically, so now looking at these numbers on the left, has grown over the past 9 years to become the most used of our push-to-bit RSS. We have drilled more than 57 million feet and have accumulated over 1 million of operating hours all around the world. So all the improvements we are here going to discuss here today are coming from this solid base of experience. This slide explains the business context that drove this need for a step change specifically for the US applications. On the left, you see the evolution of the lateral length of the unconventional wells in US land. The message is clear. These laterals were, and even in 2020, still are, getting longer and longer. The game is about getting as much as possible of lateral length and, of course, deliver it as fast as possible. This graph on the right shows that we have two opportunities to increase lateral length. First, if we can deliver a landing curve with a tighter angle, then you can increase the horizontal distance at the start of the lateral. And then second, if you can drill further out, you then increase the lateral length by pushing it steady further away. So let's go in detail through these challenges. And for this, let's consider a typical trajectory like this one here. One of the first things our customers require is to be able to drill out the cement and the casing equipments with the same drilling BHA needed for the whole hole section. Then the following sections leading to the curve can see some hard abrasive formations, hard stingers, which can not only affect the bit but also the RSS and the rest of the BHA. The game in this first part is to maintain low tortuosity while maximizing the drilling speed and keeping the BHA integrity. Then we have to build the curve, which often requires a dedicated BHA, because the dogleg demand in this curve can be very high. And finally, in the laterals, we will have to go through some formation changes, which also can require several BHA changes depending on the length and the severity of the drilling conditions. This is where, if not managed, the cumulated tortuosity will increase to its maximum, as we will drill through some formations which will try to push us away from the intended line. So at the end, if you have a drill bit which can drill the entire section, you need to match it with an RSS which can also deliver the whole run. You need an RSS capable of matching all the challenges of such a section, starting with an automated mode for the first vertical part, capable of surviving through hard stingers, then capable of delivering the landing curve even with high dogleg, to finally drill the laterals in an automatic self-driving mode to hold the line and minimize tortuosity while maximizing the drilling speed. This is exactly what we shoot for with PowerDrive Orbit G2, and here is a short movie to show you what it is.
This is the next generation PowerDrive Orbit rotary steerable system, boosting performance from the most reliable push-the-bit RSS on the market, increasing drilling efficiency, minimizing trips, and enhancing trajectory control on any rig type worldwide. Re-engineered for drillers, we reduced the distance from the pads to the bit. An additional row of cutting elements spanning between the pads and the bit play a dual role. Our cutting elements not only provide a smoother motion to enhance pushing action, they also remove abrasive features from the Wellbore wall, protecting the pads and upper BHA components. The PowerDrive Orbit G2 RSS maintains the pad metal-to-metal sealing system, which expands the operating envelope to greater flow, higher pressure, and more aggressive drilling fluids, enabling faster ROP. It can build tighter curves than the previous generation Orbit under the same conditions. This system also includes new and comprehensive 6-axis continuous inclination and azimuth measurements. The multi-axial component helps improve hold inclination and azimuth capability for accurate well placement. This feature boosts steering and well placement accuracy through automated control, delivering smoother tangents with minimal tortuosity. For drillers who want to drill wells from shoe to total depth in a single run, this is the PowerDrive Orbit G2 RSS.
Come back on the 4 main features brought forward by our new PowerDrive Orbit G2. So first, we keep our proprietary metal-to-metal piston seal made possible by these metallic balls that we have in orbit and which remain the best system we found to withstand the toughest hydraulics and fluid demand. Then to the pads, which we call Pads Tab 5. Just to give you an idea of the road of improvements we went through over 20 years to get to this latest design. Here you can see these PDC inserts we place at the front edge of the pad, which drastically increase its abrasion resistance. We also placed these PDC cutters in an active ring right before the pushing pads, between the bit and the pads. These new cutters would clean, smoothen the surface of the wellbore after the drill bit, and this will have 2 positive impacts. First, they protect the pads and all the BHA elements above from the abrasion. And second, they enhance the pushing action from the pads for greatest dogleg output. And finally, we adjusted the geometry of the tool to bring to a minimum the distance from the bit to the pads. This translates by geometry directly to an improvement in dogleg output. Features bring these benefits, which, as you can see, are focused on performance. The tool is designed for longer and tougher runs. It is capable of higher dogleg, and it is equipped with a self-driving mode capable of holding a drilling line on its own downhole with minimum tortuosity output. Within 6 feet from the bit, so very close from the bit, we have a lot of sensors, both inclination and azimuth, and an azimuthal gamma ray as well. G2 benefits from the latest Schlumberger's digital enhancements, and this helps in both the planning and the execution phases of the drilling process. Our drilling engineering centers are utilizing machine learning and data analytics to better model the whole BHA and to ensure every single run that was done by this technology is used in optimizing both the drilling and steering performances of that subject well. And moving into execution, this system uses 6-axis continuous inclination and azimuth measurements, which is very close from the bit, to drive a true downhole automated trajectory control that is capable of maintaining both inclination and azimuth as required to stay on target and minimize tortuosity. A last point on the azimuthal gamma ray, it can provide an 8-beam azimuthal image. A bit deeper on the trajectory control subject. Here we want to show the importance of the sensor placement for trajectory control. Let's consider 2 identical steering systems. The only one difference between the two is the sensor placement. On the top one, the inclinometers and magnetometers are placed 15 feet from the bit. On the bottom one, the same direction and inclination sensors package is placed only 6 feet from the bit, which is the case for our power driver G2. Both systems will react identically at this time T1 in the middle. They both have been pushed away from the intended trajectory lined by a specific formation. The difference is that the bottom system knows it, while the top system is still ignorant of what's going on at the bit. So while the bottom system can start reacting, the top systems will continue off track for a while longer. This shows how important the sensor placement is to minimize tortuosity in the laterals. And I insist, both inclinometers and magnetometers needs to be close, otherwise you only fix half of the equation. Having the sensors close to the bit is the most important for tortuosity control. But as well, and in a similar way, the frequency of the adjustments on the steering control does play as well. Additionally, the system must be able to make these measurements regardless of the drilling conditions and the azimuth. Most of the US land wells are actually drilled with a north-south heading, which is a challenging direction for measurements. You need to be able to perform even in this bearing. The graph here left shows that for us in Schlumberger, more than half of the wells we drill in the US are in this very challenging zone of exclusion north-south. With PowerDriver G2, we have our 3-axis accelerometers and 3-axis magnetometers all at close distance from the bit. We measure at 1 Hz frequency and we adjust the steering mode each minute. Furthermore, we advance the tool capabilities to be able to drill north-south with as good precision as in any other direction. BHA is of course not made of an RSS alone. It is coupled with drill bits, mud motors, MWDs, and sometimes other elements like vibration dampening devices, etc. So a BHA is as strong as its weakest element. And here we need to point that the success of PowerDriver G2 has delivered were also the success of our new MWD X-Bolt G2. These two tools are run in conjunction on our US operations and are completing each other with great synergy. The dual telemetry capabilities delivered by X-Bolt G2 complete the advantages features brought by PowerDrive Orbit G2 by connecting it to the surface in the most efficient way, reducing flat time, eliminating trips, and accelerating the drilling performance. PowerDrive Orbit G2 was introduced to the industry in 2019, and since then, in just over 1 year, has already grown rapidly. Today we are using it in 10 different countries. We have more than 500 runs and more than 38,000 hours of operations in all sorts of formations. Despite the industry's slowdown in 2020, the slope of PowerDrive Orbit G2 growth is a proof of the value it delivers for our customers. Specifically, on our US operations, we had started to implement some of the features of PowerDrive Orbit G2, for instance, the shorter bit to pad distance as early as 2018. But the full PowerDrive Orbit G2 with all the features here described were introduced in the US in the middle of 2020. And it grew very quickly as a slim hole RSS capable of delivering both curve and laterals, mainly in the Permian basins over the second half of 2020. So here is one example on the top right of the type of increase in both rate of penetration and drilling distance that PowerDrive Orbit G2 enabled. We here pushed one run, curve and lateral, to over 16,000 feet drilled with an increased ROP of about 10%. So this is just one example among many others. We have now more than 140 runs or 700,000 feet drilled, and mostly all on the Permian Basin and mostly on the tough Delaware formation, delivering these type of improvements. So this concludes our Schlumberger's PowerDrive Orbit G2 session. Thanks to all for listening in today.
It's like I've never done a live show before or something. I don't know what the deal is today. So thank you guys for being here with me. I mean, there's a lot to take in from that video. From Schlumberger's perspective, what are you guys excited about with your rotary steerable system? Shola, I'll let you go ahead and start.
Yeah, the most exciting thing is being able to address our customer challenges in the most difficult terrain in the US land. It's been a very big challenge for our customer to achieve the objective they want to achieve, especially in the Delaware Basin, drilling the curve and lateral in single run with optimal performance, with no concern of drilling off target. And being able to put the PowerDrive Orbit G2 to address this challenge specifically, consistently, and reliably is what I'm most proud about with the introduction of the PowerDrive Orbit G2.
And speaking of introduction, I messed up once again. Shola, why don't you introduce yourself, and we'll let you do it as well. Sorry, guys.
No, thank you. Thank you.
Just want to talk.
Thank you, Dave. There is a lot of things going on for sure. My name is Shola Oluwadare. I'm the North American Land Drilling Engineering Manager. I've been working in the oil industry now for over 20 years, from the field as LWD engineer, directional driller, technology support engineer, and I've been in North American land for the past almost 7 years now as a drilling engineer, and for the past 2 years as the North American Land Drilling Engineering Manager. Gio.
Oh, geez, hold up. There you go.
Thank you. Hey, good morning, everybody. Thanks to have us, David. So my name is Gilles Villiers, and I am the product champion for Schlumberger, looking after the development of rotary steerable systems in Schlumberger.
Excellent. And so the question that I asked Shola, what are you most excited about within terms of Schlumberger and y'all's rotary steerable systems?
So what is exciting, and specifically with the PowerDrive Orbit G2 we just presented, is two to go and play with the limit of what we can do, right, with the technology, to go and push the limit always further and further. And so that's the exciting part, right? So we push the technology further in tougher formations in the Delaware, like Sola just mentioned. We push the limit further in terms of what dog legs we can deliver with the systems, and also we push the limit further in terms of the level of control we have on this technology. There is a contradiction, right, between having a lot of aggressivity in the curve and needing a lot of stability in the laterals. But, you know, managing these two things, which can fight each other in the same technology, this is one of the exciting things, yes.
So I'm guessing you guys were watching the panel earlier from the operators, and one of the things the operators, you know, one of the words that we kept hearing over and over and over was reliability. How do you guys address that within Schlumberger to be able to provide the best reliability to clients, or what are you guys doing different there?
So I can take this one, Sola, right? So I mean, you've seen it in the video. The power drive of G2 doesn't come out of nowhere. It is based on a very solid technology that, in effect, we've been developing for 20 years. And I mean, when we develop a technology in Schlumberger, we continuously sustain it. We use it, we improve it. Power drive orbit, which was the previous generation itself, I mean, we've been using it for 9 years, right? And we have millions of feet with that tool from all around the world. So we have, I mean, a very long curve of improvement over that technology that power drive G2 is building on, right? So it's continuous improvement specifically on this technology. And while we explore the limits of our customers in terms of shock, vibrations, drilling north-south, we also explore these difficulties, and then we improve our technology to make sure she's doing good in every single angle.
Shola, do you want to expand on that one at all?
You know, that's exactly right, Gio. I mean, the ability to continuously improve, the agility. You know, you look at a very big company, and we come to a place where we section down our ability to actually improve very quickly and address our customer challenges. It is very important to addressing reliability, especially in the US land where we're consistently pushing the boundary. We develop the tool, we push it to the limit, we find the weakest link, then we improve it. Now, today in Schlumberger, we have improved considerably on our ability to bridge that gap of quickly redesigning and improving so that we can continue to push the limits.
So what's the kind of turnaround time for you guys to be able to spot something that takes place in the field, be able to, you know, understand, acknowledge it, come up with a design, and then implement change?
It depends. It depends on the improvements you're talking about, right? So it can be, we're doing a lot of work lately on the digital side of the technology. And so we have brought a lot of things when we talk about controls, right, of these systems. This is, and we heard our customers as well, right, talking a lot about automation. So we are making, I mean, massive improvements on the digital sides to automate our systems step after steps. And these improvements on the software side actually it's going quickly. If it is a hardware improvements, then this is something we will want to V&V when we have an idea. We will want to test it in V&V conditions. We will want to test it on our test rigs before we bring it full blast to our customers for tests. So it can take a bit longer on the hardware, but it really depends on the type of improvements you're talking about.
So it's very interesting you say that, because then that's kind of like what Tesla's been doing with vehicles, is that you can make a lot of advancements to the vehicle by just changing the software or firmware on the vehicle. Is that something that you, like a similar methodology or process that you guys are putting into with the rotary steerable tools?
On the digital side is a big part of what we do, yes.
Excellent. All right, any last words from you guys? I put the timer on. I think we're almost out of time. But any last words from you guys? Thank you guys so much for being here, by the way, as well.
It's a pleasure.
Thank
you.
Maybe
from you, sir?
Maybe just last, I mean, if you guys want to know more about the technology, we have plenty of resources on our website, so you can go and surf there. But David, thanks again for having us.
Yeah, thank you, David.
So thank you guys so much. I do appreciate it. It's great to be able to see my alma mater, because that's, I mean, that was the company where I got my start at, offshore Brazil. So I was working with Schlumberger. So thank you guys. All right. So next up, all right, I am just, Okay, can I remove this? Remove from studio. There we go. All right, guys. Next up, we have got the industry experts panel. So some of the people, a lot of these tools that we've been talking about so far, we're about to bring on some of the people that were either instrumental in the business development and go-to-market strategies with some of these tools, early engineering, design and development. Absolutely amazing people. Let me get over here, hit the thing. Where's the button? Where's the button? Where's the button? And this presentation, by the way, let me pull this up. This is brought to you by Cougar Downhole Drilling Solutions. Let me see. I have a little thing to be able to read. Brought to you by Cougar, leading the industry in analysis, mitigation, downhole drilling, and dysfunction. Check out the new website at cougards.com. Expert speaker 6A. And then let's get everybody on the stream. So we've got Neil Armstrong from Merlin ERD, John Clegg, George Sutherland, and Jeff Lassiter, Neil Bird, and Blaine Como. Does everybody fit? They all fit. Well, we got to switch spots, Neil. There we go. All right. We'll go around the room real quick. We'll start with Neil, then Blaine, Neil, again, George, Jeff, and then over to John. You guys introduce yourselves real quick. Tell us who you are.
Okay, I'm Neil Armstrong. I'm the engineering director with Merlin ERD. So we're a drilling engineering consultancy company that specialises in providing solutions for complex wells. So not just extended reach wells, just high-angle wells or wells with issues and managed pressure drilling. So I haven't designed a rotary steerable tool, but I've been involved with multiple hole sections where rotary steerable systems are the only option, for the last 20 years, where wells where motors really are not a viable option at all. So when it comes to rotary steerable systems, I wouldn't say I've seen it all, but I've seen some incredible successes and I've seen some baffling failures as well.
All right, Blaine, over to you, sir.
Thank you, David. I'm Blaine Como. I'm a senior technology consultant with InTech Consulting. 30 years with SabRE drilling, and at one point I was the global product champion for the GeoPilot rotor steerable and saw the launch of that in the United States. And currently I'm also affiliated with the International Association of Directional Drilling, and I teach an introductory course on rotor steerables where we do basically a survey of all the existing tools. So yeah, glad to be a part of this today.
And Mr. Bird, over to you.
Hello, I'm Neil Bird. I work for Enteq Upstream as a product director. Previous to that, I've got 25 years experience now on rotary steerables, from, well, initially breaking them in the field to coordinating tech support position, engineering positions, and currently at Enteq working on a new tool that we'll mention later.
All right, and then over to George and Jeff.
Hi, I'm George Sutherland, and I've got many years in this upstream oil business, pretty much all of it in directional drilling, MLWD, and rotary steering. I've been 13 years at Schlumberger, about 12 at Halliburton, and in between there, I hooked up with this guy, and we developed a company called RST, which was rotary steerable tools for the first rotary steerable ever run in North America. And I've been part of a lot of the operation business development side for many rotary steerable commercializations. So that's me.
I'm Jeff Lassiter. I started my career in the space business, in the human space business. And then I came over to the dark side in 1997 when I met George and a guy named Steve McLaughlin, who started RST. And somehow I landed smack dab in the middle of the early rotary steerable days. So anyway, went back to the space business for a little bit, and then got called back to the industry and decided to do things a little differently for downhole control and steering. We started Kinetic Upstream in 2016 and have spent the last 4 years or so designing, developing, and early commercialization of a new rotary steerable, of the Contour tool.
All right, and John?
Hi, my name's John Clegg. I've been in the industry for 35 years, and 30 years ago this year, started working on my first rotary steerable project. It was actually started out as a directional steerable drill bit for Hycalog. that very quickly became a directional steerable near-bin stabilizer, which turned into what eventually became Schlumberger's first generation power drive tool. So I worked on that for about 10 years. I tell people my very first RSS run was at Montrose in Scotland on a Kelly rig, and a lot of people don't even know what a Kelly rig is these days, so that shows how long ago it was. I've worked on a variety of drill bits, downhole tools, rotary steerables since then, most recently Weatherford's Magnus tool, and I am now kind of semi-retired, although busier than ever, and consulting.
All right, guys. Well, thank you all for being here. I'm guessing you guys all heard a little bit earlier when we had the operator panel, and one of the biggest things that was being addressed there, and I want to be able to ask the panel, is going forward with rotary steerable tools, how can we do better as far as increasing reliability or being able to convey the reliability of these tools? And John, we'll start with you.
Okay. Well, go back to that first run of the rotary steerable in Montrose, and I remember we drilled 2,000 feet on that very first run, which sounds impressive, but I actually checked. It said an SPE paper we wrote. We actually did it in 20-bit runs, so we've come a long way since then, right? I think simplicity is a big driver in a lot of the things that we had being talked about throughout the whole day. Not only reliability, but also things like cost of ownership, lost in hole, cost of operation. So I think there was a time when all that really mattered was dogleg back in the 90s, and then all that really mattered was sort of reliability and MTBF. I think now it has to be a ticket to the game to be able to get to TD, or at least to be able to get to the end of a bit run with a rotary steerable system. And I think there are other requirements beyond reliability now, but I think reliability has got to be a ticket to the game.
George and Jeff?
I'll also make a comment with respect to reliability. Reliability is job one, right? I mean, if you're not reliable, you're not going to be the lowest cost. You just don't have a chance for that. If you're tripping, you're not low cost. So reliable has to be job one. And when I think of reliability, I think what operators really look for, even on U.S. land, is the shoe-to-shoe, as John says, get to the end of the section. But consistency is important. They need to be able to predict how their drilling program is going to go. And so, and you need to have a continuous improvement process as well, and make sure that you put these tools in the right area for success, right? It's kind of horses for courses in some respects. You got to make sure that you're putting it in the right environment. I remember being in MWD early days and drilling, say, East Texas, Cotton Valley, and you would dump MWD tools out of in a bucket. But today it's routinely done. So, downhole technology has come a long way. There's a lot of tricks to the trade, as we all know, and getting that right is first, but you have to continue to improve as well going forward.
Yeah, I might add one thing. I mean, how do you compete with, the big guys, and how do you get to reliability? You can either do it with 1,000 runs, or you can have a really fast feedback loop between your engineering and operations. And when I say that, I mean, we all have engineers going to lunch with our operations guys, going to lunch with our sales guys, and our engineers hear it immediately from the field when we have an issue. And that gets fixed within, a day or two. So having that quick turnaround and that quick loop time feedback loop is really vital.
All right, Neil, I know that you've been a part of, designing several tools. Any thoughts from yourself on that?
Well, I'd follow on from what Jeff said. It's very hard for the new companies to compete against the big boys. If you look at the reliability levels today of PowerDrive and AutoTrack, who are the two dominant tools in the market, it's phenomenal. It's really high. 20 years ago, not at the same level. Any new technology coming in now has to be pitched in a way that it can be at or close to the reliability of the big two. So we have to look at more innovative ways of testing tools, getting downhole hours on tools, etc. In the marketplace at the moment, I don't know, 15, 20 companies knocking around in the marketplace. the majority of the work goes to 2 companies. That's a unusual balance given it's a 20-year-old technology now, and that needs to change. So there has to be focus for the newer companies coming in on how they actually get the reliability to the competitive level quicker.
So going off of that, Blaine, you know, obviously you were instrumental in being able to bring tools to market. What are some of the strategies that you would put in place as far as being able to you know, get new tools to market and be able to talk about, you know, how they can be reliable and how they can be a cost-effective solution?
Well, I think there's a lot of homework that needs to be done to make sure that you're actually pitching your tool to a client who has an application where your tool is going to be successful. And I think we saw some of the things with the different systems this morning and the different sizes and different capabilities, and you know, tools that were specifically designed for the U.S. land market, for example. And I think that when you are careful with screening the potential applications where your tool is going to have the greatest possibility of being successful, you're doing yourself a favor and you're also doing your clients a favor. Not all tools are made for every market. Not all tools are made to address every application. Some tools do better in different situations, and you need to play to your strengths, basically. If you're going to take a tool out there and present it to the world, you'd better be careful about, you know, who you're actually taking that tool to ensure your success, as well as, you know, maximum success for your clients and the reputation of your product.
Excellent. And then Neil, you know, obviously, like you said, you've been a part of, you know, managing or engineering some of these wells using rotary steerables. How do you go about, you know, evaluating what's best case use scenario? And then if you can you share some of the follies without mentioning any names?
Yeah, no, I don't mind mentioning names, David. Not at all.
I don't think all the listener, well, I mean,
just as long as it's not any of us.
Tools.
But I mean,
you basically got. Sorry, Neil. Oh,
sorry, was that for me? Was that for?
Oh, yeah, Neil Armstrong. Sorry, I apologize.
Yeah. Okay. Yeah, I think Blaine kind of hit the nail on the head here. You know, it's horses for courses. You've got to make sure you're selecting the right tool for the right job, and also when you're assessing the tools, you've got to make sure you're looking at the right data to assess whether it's the right tool for the right job. You know, for example, I was involved with a well. And we were trying to, you know, we had a 12.25-inch hole section that was 25,000 feet long, about 88 degrees, almost the entire section. And we wanted a tool, and we were tripping on singles once we got deeper than 25,000 feet. So it was going to be a slow trip if we had a failure. So the critical thing was we wanted a tool that could get us to TD shoot to shoot. So we spent a lot of time looking at the data and comparing tools. And so we were looking at the Exceed tool at one point versus the Power Drive tool. And it looked like the mean time before failure for the Exceed tool was worse than the Power Drive tool. But that was because when we looked at it in more detail, the Exceed tool was being used in different applications. It was being used in tough, abrasive drilling conditions. It was being used in intervals that were that had hole enlargement, so that, you know, where you couldn't get pad force from a push the bit tool. So inevitably, it had a higher failure incidence, but it actually turned out to be the best tool for the job for us, and we went with that tool, and it did a brilliant job. And one benefit of that tool was it didn't have the pressure drop of the Power Drive. So for that extremely long hole section, that allowed us to clean the hole and have flow rates that still clean the hole at TD.
And it's exactly right. I might add, Neil, also that the benefit of being a new product on the market, and maybe even in a small company, the benefit is you get all of the worst applications. You get selected for, you know, somebody, an operator, a DD company will say, hey, I got a great application for you guys because none of the other tools will work for this.
Yeah.
So how about you guys give it a chance?
It's easy for me to say horses for courses, but when you're looking for runs and proving up technology, you don't want to miss opportunities to get in the hole. But unfortunately, that tears you apart. You got to try to stay disciplined and go in the areas that the technology, the cards are with you. And it's difficult sometimes because you always get pulled where the others can't succeed.
And I guess that's survival of the fittest, though. If you're if you're a better evolutionary step from the previous one, then I guess you get to walk out of the water.
And the survival of the fittest often comes down to how quickly you can adapt. So being a small company, if your feedback loop is faster, more responsive, then you'll thrive.
All right, so we did have a question come up. I don't know if we can get this whole thing on the screen here. How do you guys think the development of technologies to improve standard motor BHA drilling is still valuable? No one is going to invest in it. I'm working on slide. Okay, that's just too much. All right, we're going to go back to this question. What are some of the main sources of failures? Guys, try to keep the question short so it's easier to read. What are some of the main sources of failures that y'all have seen?
Where shall we start? Any kind of mechanical component, electrical, everything. I mean, a rotary steerable is. Here's the thing, the industry is really, and I don't mean this in a bad way, but used to kind of dumb iron. It's used to simple devices or devices that are in certain silos, and a rotary steerable is like it's like a spacecraft. It has multiple systems. It's a system of systems, and so you've got when systems don't work with other systems or they're not compatible with other systems. You have a cascading effect sometimes. So you have bearings and seals, and then that overheating makes them become an issue, and then the software can't keep up with it. And now you've got an incompatible system. So,
keyword there being system. It's a complex system of things. So there's a lot that can go wrong. And experience and iterations and testing help you solve that.
But you also have to be able to, to design a tool like a rotary steerable or an advanced steering system like this. You've got to have all the disciplines, and that's hard to do with a small company. You've got to have people that can zoom in and zoom out very, very rapidly. So, that's what we look for in our actually when we bring people on, their ability to look at the micro and then look at the macro, because as we know with BHA modeling, for instance, the micro affects the macro. A butterfly flaps its wings in Africa and you have a hurricane in Houston. So
Neil Bird, why don't you jump in on this one, please, sir?
Okay, most of failures roots comes down to vibration. Downhole vibration is the most significant, probably failure mode. Regardless which component finally goes, it will come down to vibration. So tools that are built need to either able to handle the level of vibration you'll see in a rotary steerable environment, most typically beneath a motor nowadays, or be able to mitigate that vibration. So there's a lot of work and there's a lot of companies out there putting things forward for that. Obviously, Tomax being an obvious example in terms of vibration mitigation. So being able to either handle or mitigate that vibration is key to a lot of the failures.
So John, I want to jump over to you. What do you see as some of the new things that could be innovated in the industry as in terms of rotary steerable tools?
Okay, well, I think there's a couple of areas, and one of them would just stick on failure. And Neil made a good point about vibration. And one of the things we've seen emerge, especially in the Permian, I think, but in a lot of like high-speed drilling of hard rocks, is much high prevalence of high-frequency torsional vibration, which is actually pretty difficult for a lot of rotary steerable tools to manage by themselves. It's basically you get excitation of the natural frequency of vibration of the tool. And since the tools are all about the same length and the same diameter, they've all got about the same natural frequency, so they're all going to be afflicted. So there is definitely a prize to somebody who can mitigate or eliminate that by means other than just backing off on the weight a little bit, which is maybe what a lot of people should be doing in the short term. I think the other thing, and we heard it talked about a lot in a lot of the presentations, is automation. And I don't know, some of you might have seen it. I'm currently doing the SP Distinguished Lecturer Tour, and I'm banging on to anybody who'll listen about wellbore quality and the importance of drilling smooth wells for completions and production, and the impact that drilling can have. And I think the RSS has a definite role to play in improving wellbore quality. I think it's ultimately, if the tools are designed right and used right, going to be sort of more capable of doing that than motor-based systems. So things like more automation of directional control and more interaction with the surface in terms of understanding how to navigate more smoothly and more accurately. And I think those are areas where innovation should come and should help.
So on that same topic, Neil, we'll jump over to you. As far as being, in consulting and being in charge of engineering practice, how much does the wellbore quality role and RSS, how much does that come in together in your decision-making criteria as far as, training or developing a drilling program?
I mean, the wellbore quality is absolutely critical. I mean, it's critical in terms of our tool selection. It's critical in terms of the operating practices. Because it drives everything. We need to be able to get the tools out the hole, and then we need to be able to get the pipe, whatever pipe we're putting back in the hole, and that's absolutely critical. Whereas a lot of the conversation earlier today was just very much focused on bottom drilling, but really, it's the borehole quality that is absolutely critical. So we're talking there about, when I'm talking about borehole quality, just so people understand, it's drilling a smooth wellbore with minimal tortuosity, and tortuosity is unwanted dogleg, and it's drilling also a clean hole. And to be able to drill a clean hole, we want a rotary steerable tool that's not going to limit us in terms of rotary speeds or flow rates. So those are the critical factors. But in terms of sort of training, it's really, by that stage, it's making sure people know what their limitations are, what you've got, what your boundary conditions are, and then working within them, and using the the tool to its full capacity. So using the full rotary speed range in order to clean the hole, and then also making sure they know what they need to get the tool out of the hole safely.
So, Blaine, I want to jump over to you and get a question for you, sir. Obviously, you've been teaching a rotary steerable course within the IDD, so big shout out to IDD. What do you see as far as the number of people that you've trained and stuff? Where do you see maybe the education gap is that's in the industry that we might need to be able to bridge more, or we need from the technology providers to be able to put out there more? What is it that we as an industry need to know more about?
Wow, that's a wide open question. And I also want to preface this is an introductory course. So the people who've been attending have been from a very diverse background and not necessarily senior drilling engineers. Although I will say that I actually had Paul Pastusik sit in on the class last time. So that was quite an interesting addition to the attendees. But I would say that, there's been a lot of talk about wellbore quality, and yet in our very first operator panel, there was only one operator who even said anything about the future ramifications on the production and the completion side of things that they were concerned about. There's a lack of acknowledgement, I think, but a growing acknowledgement within operators that there's a total cost of ownership that has to be understood, and what happens when we drill the well has a lifetime effect on that property and how much it costs to run that and maintain that well. And so I think the area of tortuosity, micro tortuosity, wellbore quality, there's been a lot of talk about this, and I'm excited to see that. I mean, we drilled wells way back when where we were using the friction factor as the only way to really know how good the wellbore quality was. There is no sensor that can detect micro tortuosity that would ever be run on a live well. There are sensors that can come in after the fact, but the problem is it's too late by then. You allowed the micro tortuosity to occur, and now you're just stuck with dealing with the consequences of it. So that whole area of a deeper appreciation for the nuances around what does this wellbore quality thing really mean, I think that's been a healthy dialogue that we've seen more of in the industry. And I, for one, would like to see that, because the only way to not have problems with micro tortuosity is to make sure that it never happens in the first place. And all the attempts to try to measure it are sort of band-aids after you've already let the wound get inflicted. So I'll just leave it with that.
Guys, thank you guys for your time. We're trying to get back on schedule with this. We're cutting this one just a hair bit short, but I got to get back on schedule, because if we don't, then LinkedIn cuts this off at the 4-hour mark. So thank you guys all so much for being here and sharing your expertise with the industry. If any of y'all out there that are watching are trying to be able to get in touch with these guys and want to be able to know more, I can say this without any doubt in my mind, that they are all very willing to be able to respond to emails and give you their thoughts and opinions and stuff. So be sure to reach out to them, ask them some questions, and learn something more about our industry. So once again, this panel has been brought to you by Cougar, leading the industry in analysis, mitigation, downhole drilling dysfunction. Check out the new website, cougards.com. Thank you guys for being here. Neil Bird,
it's a pleasure, Dave.
It is your turn, sir. So I'm going to kick everybody else off here, and I got to take this thing off too. It is your turn to be able to present, and thank you, sir. Appreciate you being here.
Share screen. Is that clear, David?
I didn't see any share screen come up just yet. And thank you guys all for watching this today. We do appreciate it. If you are still watching, be sure to like, share, subscribe, do all those social media things. And if you guys didn't notice that Enteq did release their tool yesterday, or made a post about it yesterday. So I'm really excited. Oh, there it is. All right, I can get off the screen.
Okay.
Yes, you're good to go.
Okay, thank you. Well, thanks for the time. And my name is Neil Bird, Product Director at Enteq, and this is a brief high-level overview of our just released SabRE rotary steerable tool. So to begin with, SabRE, what does the name mean? It's steering gap bit Enteq rotary steerable. What we wanted to do in the name was capture the fact that this tool is an at-bit steering tool. It generates a side force directly at the bit, and the way it does that is unique to any tool on the market at the moment, which I'll cover as we go forward. Some of the history of the SabRE tool. SabRE originated as a Shell research and design project. Shell did the initial modeling, they came up with the concept prior to that, modeling and the verification, and they took it through to a proof of concept prototype. This iteration of the tool that Shell had went downhole as a prototype tool, and again verified that the concept gives control and dogleg. In 2019, the IP was transferred under license to Enteq. Enteq accumulated a team of engineers. Combined, there's more than 150 years of actual RSS experience in there, quite a bit of grey hair as well. And their first task was to revalidate the results from the Shell modeling, their historic test results, and review the prototype equipment that we received from Shell. So based on the back of that, we commenced a re-engineering project to develop the commercial system, which was initiated a year ago in March 2020. Now, this isn't a prototype tool. These are intended to be commercial tools building on what Shell has already put in place. So at the moment, we're testing individual components. In about 4 weeks' time, we'll have a complete system for bench testing and lab testing, then progressing on to field trials and downhole testing in the middle of the year onwards. So how do we do it? So let me just go back up. If you look at the picture on the left, it's fairly clear that this tool is slightly different in the fact that it doesn't have any mechanical pads. That stabilizer you can see is an integral blade stabilizer, and it doesn't have a non-rotating sleeve. So how do we achieve side force and therefore dogleg? Well, Saber's primary steering characteristic is based on Bernoulli's principle. So if you look at the illustration on the left, it's a standard bit, 6 blades, 3 blades, approximately meet in the middle, and for this example, it's got 3 nozzles. Now, if we were to preferentially divert flow through nozzle 1 in preference to nozzle 2 and 3, what we'd end up having is higher velocity going through that segment of the bit. By Bernoulli's principle, higher velocity equates to lower pressure. So if you look at the CFD analysis here, the blue shows the lower pressure areas and green is higher pressure. So now we have one segment of the bit with lower pressure. Effectively, this pressure differential then acts along the bit blades and down the jump slots area of the bit to give us the force in the direction illustrated here. So if we can preferentially control flow through the nozzles of the bit, we can achieve Bernoulli's principle and generate the required side force to get dogleg severity out of the tool and control. So mechanically, how we do this is what we call a 500 series. These are the first tools we're building. It's a 5 1/8 OD body, capable of 6 inch through to 6 3/4 inch hole. Basically, we have a sonde inside the collar. It's a non-mag collar, 6 foot long. The sonde components you can see are approximately 5 foot long. The whole intention of this is to control a valve assembly inside the bit box in a fixed orientation that we can control and move as required and hold geostationary when necessary. So how do we do this? We basically have 2 impellers on the tool, one clockwise, one anti-clockwise, which we oppose against each other to control the position. So the whole tool is floating on a series of bearings. So coming back to vibration, this tool is decoupled from the string rotation and therefore should not experience the worst effects of any torsional vibration that was previously mentioned. So we have one fixed impeller. This is fixed to the body of the sonde. This rotates anti-clockwise with flow. That's its only purpose in there, is to rotate the whole tool, sonde assembly anti-clockwise. The second part, and this is the clever part, is the generator. The generator provides power, interprets a downlink, but most critically, we have an electromagnetic brake function on this generator as well. The generator rotates clockwise relative to that anti-clockwise impeller I previously mentioned. And by controlling the braking effect on this generator, we are able to allow the tool to go anti-clockwise on the valve, clockwise, or hold it geostationary by balancing the 2 impellers. And that is how we hold the impeller, the valve assembly in the bit in the orientation to divert the flow through the nozzles that we prioritize. And immediately behind there, we have the control electronics, effectively 2 boards and a small micro hop board. The 2 control boards, one is a rectifier circuitry to control the generator and the braking functionality, and the second is the navigation unit, triaxial accelerometers, magnetometers, and we've also included a triaxial MEMS package in there as well for control, and that's for feedback. This is all well and good mechanical implementation. It's a very clever design, it's a very elegant concept, minimal moving parts, the simplicity is great, but this has to relate to something tangible to the client. So if you look at the collar from the side, it's featureless other than the stabilizer. We don't have any significant pad areas or machining at the collar. I mentioned previously that we are decoupled from the worst of the torsional vibration because we're floating on a bearing assembly. Theoretically, that gives them no maximum RPM limits on our tool can tolerate. Weight on bit transfer, we don't have a drive shaft. We don't have pads that stick out. The collar is a solid collar with minimal machining. Again, our weight on bit transfer should just be controlled to what the bit can take in the formation. And finally, in terms of this, our temperature spec for the tool, by June, this will be a high dogleg 175 degree or 350 C Fahrenheit tool. So how does it fit in the BHA? Obviously the RSS is just one component in the BHA. We've tried to make our BHA options flexible and we think we've succeeded on that. What you can see here is our idealized motorized BHA. It can be run motorized or non-motorized. In a non-motorized configuration, the motor just drops out of what you see above. So how does it work? We have the rotary steerable at the bottom. We use a small, I mentioned, micro hop transmitter to go to a sub behind. That sub would have azimuthal gamma capabilities or azimuthal resistivity imaging capabilities. And from there, through an EM short hop, we can transfer to the NWD system. And our preference would be to put the NWD system above the motor to protect it from the worst of the vibration. And that could be preferably Enteq's NWD system or any Q-bus NWD system. We have the option for a flex or a stiff collar that will change the dog leg by about 25%. In the flex collar version, we're looking at an 8-degree dog leg tool from this system, slightly less if you go for a stiff collar, depending on application. And if required, you can drop out the azimuthal sub, gamma sub in there, and you can run the tool blind and in that configuration, which probably means I've slightly overrun my time on this topic. What I would say is we have an email set up, saber@enteq.com, and if anyone wants to reach out to me and ask any further questions or details, we are now in a position that we will start talking to clients, etc. going forward. So,
oops, wrong. There we go. Neil, thank you guys so much. It was really interesting to be able to hear about that. I know with the press release that came out yesterday, made me really excited to be able to see your presentation today. Thank you so much. All right, guys, on to the next one. We've got, this one's from Wolverine. Here we go.
My name is Ian Cook, president of Frontier International, based here in Houston. Pleasure here to be presenting on behalf of Wolverine Oilfield Technologies. And thank you to Gibson Reports for allowing us the opportunity to present today. Yeah, I think 2020 has really taught us about you know, the resilience of not only the oil field, but obviously the introduction of new technology as well in a very subdued market. Wolverine has obviously launched its remote series Zenith RSS, and really the attributes around that were really based on the industrial challenges that we present here today in terms of complexity, reservoir access, drilling longer, deeper horizontal wells, optimizing drilling costs on a continual basis. It's not just not once, it's continual. Improving reservoir recovery is ultimately the key element of this, and how drilling and obviously technology enable this. Well design and drilling practices are continually getting better, continually being optimized. Obviously technology being a key part of that with real-time decisions. And then technology, how that really fits into and addresses these industrial challenges. And we believe that going forward that these challenges and these structural changes that we're currently seeing with reduced personnel on location, obviously more remote operations and automation to improve not only consistency but also reliability as well, is going to be really the key differentiators moving into this new drilling norm that we'll see through 2021. Our market approach to Zenith has really been about how we address the industrial challenges with technology, and equally important is how do we address the structural changes within the OFS that we'll see with 2020 being the showcase with the pandemic, and obviously into 2021 and beyond, and how technology can address remote monitoring, remote access to wells, less POB on location, as well as more automation. Some of the key attributes and differentiators for the remote series Zenith RSS include full integration with high-speed MWD to Zenith itself, an industry first. Meaning one tool which can be assembled and programmed in any facility globally, installed with no directional service personnel, and can be run remotely by expert staff if this is a true requirement. This function formed part of our first commercial run for an international oil company. Additionally, this tool can be used as an open platform for other commercially available MWD systems such as Toltec, Tensor, and APS. The next slide will give us a brief visual of the technology highlighting the Zenith attributes and some of the product features. The Zenith RSS with integrated MWD features a field service-able bias unit with integrated azimuthal gamma, directional sensors, and bore and annulus pressure. A standard MWD battery is used for surveys, along with a downhole generator for circulating power with real-time sensors, and flow-off survey data is transmitted through a high-speed top-mount pulsar. Other sensors include near-bit AS, gamma, and real-time inclination and AS, enabling quick and accurate geosteering decisions. From a performance standpoint, each pad is controlled independently. Additionally, by measuring pressure under each pad, additional real-time information is provided on tool health downhole. The entire assembly is built and programmed in the shop for a true hands-free field operation, which can be picked up in a single collar and comes in a 30-foot single length. The Zenith tool completed its first commercial operation for an IOC with tremendous success. The Zenith RSS was chosen for this operation based on the geosteering requirements of the customer and its proven accuracy in field trials. Platform for remote operations and the inability for expertise to be on location during the pandemic, as well as its ability for high-speed telemetry, improving real-time well placement. The BHA included the Neutrino Ultra High Speed MWD, the MFWPR Resistivity LWD, and Pressure During Drilling tool, and obviously the RSS. The run successfully built from 84.5 to 91.5 degrees and completed a tangent section according to the geosteering instructions from the customer. This system was able to receive downlinks without failure, with no requirement to stop drilling in order to change the steering vector. An average ROP of 52.5 foot per hour and a maximum ROP of 75 per foot per hour were achieved while drilling. In summary, if you believe these industry structural changes and the new normal for drilling operations are here to stay, then understanding and embracing new technologies such as remote series Zenith RSS will be required to enhance drilling operations globally. We believe Zenith will be a backbone for all drilling programs in the future. One well, one tool for all your remote directional needs, RSS through LWD and high-speed telemetry. Again, I'd like to thank Gibson Reports for the time and opportunity to present today. Our contact details are included for future. Please reach out to us to learn more, and thank you very much for your time today.
Awesome having the guys there from Wolverine, and it's kind of cool because I used to be part of things not working right. I used to be a part of one of the sister companies, NewTek. I was actually a chief technology officer there for quite some time. All right, so next we've got Compass Up. And they're debuting a never before seen tool. Here we go.
With a goal to provide global customers a directional system.
I don't see it.
With a goal to provide global customers a directional system that is easy to use, high performance, cost effective, and reliable, Compass has taken decades of industry best practices to create a flexible and modular system that can run in any combination of MWD, mud motor, or LWD from compatible brands. Its short length makes it a perfect RSS combination with an MWD below a mud motor to increase RPM and ROP. We've created a system with infinite possibilities, built to cut operational costs by 50% over existing RSS technology. Reduce operational costs with an RSS system that is 50% less to purchase, 50% less in length, and 50% less maintenance. Do more with less as you optimize your assets. Use Infiniti to drill vertical and create your curve with a maximum build rate of 20 degrees per 100 feet. Infiniti provides continuous at-bit inclination monitoring and optional near-bit azimuthal GR with a high-speed MWD data rate. Drill verticals, curves, and horizontals in one run. And due to Infiniti's 5.5 foot length, you have greater agility. And what's more, you can receive better geo feedback from resistivity modules that sit closer to the bit for greater control. Infiniti RSS may be operated in self-drive mode and can integrate with supported MWD/LWD tools. It includes its own downlink and does not rely on other tools for downlink and self-drive mode. In addition, Infiniti RSS is integrated with Compass MWD tools and can integrate with other MWD systems as it is built to be non-proprietary with standard architecture. In the integrated mode, a signal is sent to the above tool, which then relates it to the surface, offering the current status of the tool, confirmation of command received, and continuous azimuth and inclination. And of course, we built it to work with any existing remote operation while fitting into your existing data infrastructure. Once your well is complete, get ready to move on to the next. Back-to-back work is a snap. Infiniti RSS is built for local and fast maintenance. That's right. Infiniti doesn't need to go to a maintenance base. With minor maintenance work that can be done with regular tools you already have on site, Infiniti is ready to go to the next rig. Cut your operational costs in half compared to other existing RSS technologies. Soon to be available for rental or purchase. Be sure to sign up to Compass's newsletter for more information and be the first to download our Infiniti RSS flyer at compass-mwd.com. Oil and gas drilling is a hostile activity. Billions of dollars are lost each year to non-productive time, and one of the major contributors is excessive shock and vibration. SoftRide is a cartridge-based rough drilling solution designed for retrievable and non-retrievable MWD systems. No need for your UBHO sub. The SoftRide cartridge comes with its own. With 72 positively engaged spline teeth, SoftRide gives you the most positive orientation available. This tunable stick-slip section can reduce the harsh effect of any potential stick-slip event. Wave springs and other internals not shown here deal with axial load to help mitigate shock and vibe. This axial section helps MWD tools to ride in a more controlled manner by decoupling from the bit, motor, and agitator. Our customers have indicated that the SoftRide design also creates a flow that goes from turbulent to laminar condition, creating less noise and less turbulent flow of mud hitting floats above the motor.
All right, guys, that was a video over there from Compass. Thank you guys so much for debuting your technology here on this event. All right, next up, we've got Baker Hughes.
Good morning and good afternoon. Good morning and good afternoon.
Click it again.
Good morning and good afternoon, everybody. My name is Brian Shires, and I am the North America Land Sales Director for Drilling Services here at Baker Hughes. Thank you, David Gibson and Gibson Reports, for allowing us to come on today to talk about our Lucida Advanced Rotary Steerable Service. We have integrated hardware, software, automation, and remote connectivity to deliver a new way to drill. The service is based on a completely new platform. The platform will enable remote operations, reduce human error, and is also a step forward into fully automated drilling by leveraging our iTrack system to improve overall efficiency. The Lucida service brings new levels of understanding to what happens downhole. It brings us more clarity. Lucida will allow our customers to see more and earlier than others. As we move forward, I'd like to share a quick video with you all to highlight the overall service.
Baker Hughes has integrated hardware, software, automation, and remote connectivity to deliver the Lucida Advanced Rotary Steerable Service, a new way to achieve exceptional drilling performance, exact well placement, and superior wellbore quality. Lucida's robust integrated bottom hole assembly with a fully customized drill bit specifically designed for each application lets you maximize penetration rates and get precise directional control with Lucida's premium cutters and advanced drill bit directional control features. Optimize energy transition with real-time dynamic sensors integrated into the steering unit. Extend the operational envelope to tougher, hotter, and deeper environments with full multi-chip module MCM electronics. With 16-sector gamma ray sensors positioned close to the bit, Lucida delivers real-time formation data that lets you navigate the reservoir precisely, make quick decisions to geosteer or geostop, hit geological targets the first time with no sidetracks. Lucida's automated well path trajectory control system integrates both azimuthal and inclination hold modes with continuous proportional steering, letting you automatically correct wellbore trajectory for any formation trends. Check azimuth and inclination every millisecond. Automatically adjust steer forces second by second for precise control, even at very high penetration rates. And Lucida is fully enabled for Baker Hughes remote operation services. With experience from thousands of wells, our drilling and evaluation experts use proprietary systems and advanced technology to execute remote drilling operations and deliver consistent results everywhere. Exceptional drilling performance, exact well placement, superior wellbore quality, all delivered by the Lucida Advanced Rotary Steerable Service, a new way to drill.
I hope everyone enjoyed our Lucida technology overview video. As we began introducing the Lucida technology into the U.S. land market, we leveraged our service expertise familiar with delivering record-breaking performance with our other rotary steerable technologies. Tapping into this knowledge base has allowed us to shorten the learning curve for building parameter mapping for our new Lucida platform. By leveraging this expertise, we have been able to accumulate over 8,800 circulating hours and have drilled 680,000 plus feet. Along the way, we have delivered 4 mile-a-day wells where we drill 5,280 feet or better in the Marcellus and Permian basins. Given that we are focused on performance, we maintain the necessary flexibility with our commercial models to ensure we are aligning our and the operator goals with a solution that creates win-win economics for both parties. For more information about our Lucida technology and how we can enhance your drilling program, please follow the link above, which includes case histories and so on. Should you have any additional questions specific to your area of operation, please feel free to reach out to me at brian.shires@bakerhughes.com. Thank you all. Goodbye.
All right. Dang, come on now. There we go. Get in focus. All right. Thanks, Baker Hughes, for that video. We've got one last lightning pitch presentation for you guys, saving the best for last. Here is Weatherford.
Today, we would like to talk to you about Weatherford's rotary steerable systems. To begin with, some background on why rotary steerables. In its pursuit to supply hydrocarbons more efficiently, operators are committed to deliver wells on time, on budget, every time. So consistency is a must. This has encouraged multiple service companies to introduce many new rotary steerable designs. Here at Weatherford, we believe that dependable rotary steerable systems tied to an effective drilling engineering process through digitalization and automation are the foundation of a new era in directional drilling. Weatherford's first rotary steerable offering was introduced in the early 2000s. It was based on the point-a-bit concept. Then, in 2018, Weatherford launched a disruptive generation of a push-the-bit rotary steerable design, Magnus.
When we started design work for Magnus, we knew we needed a step change in our product offering. We needed to stand back, look at what we had accomplished with previous tools and say, okay, we've done it once. How can we execute it again, and how can it be done better? For many years, Weatherford had been working with our clients and understanding that they needed 4 key elements in any rotary steerable tool design. First, they needed a successful tripping operation. Tripping down through casing or liner or open hole with a minimum of formation damage. The next operation was going to be drilling. That's what tools are really meant to do. They drill wells directionally. For designing these tools, we really focused on making the assembly rigid and reliable. And what this does is it enables the clients to deliver maximum weight on bit, maximum torque on bit, things that they need to achieve successful operations as quickly as possible. The third part that they needed us to accomplish was a successful tripping operation out of the drilled hole. Now this is where a lot of tools cause a lot of trouble. This really caused us to focus our design on slimming the tool as much as possible, getting it down to the absolute minimum diameter. All of our tools are designed such that they're 1/4 inch undergauge both at the pads and at the stabilizers. This allows us to trip on elevators more reliably, more often, all the way to surface, again with a minimum of rotation and a minimum of flow required to get out of those open formations. The final benchmark or judgment passed on a rotary steerable tool design is whether we were able to get liner or casing run all the way to total depth without delays. Again, did the tool drill successfully without producing ledges or tortuosity in the borehole? And this is where our proportional control really shines.
I want to talk to you about one of the key features of the Magnus rotary steerable system, independent pad control. The Magnus system is equipped with 3 independently controlled pads and valves. With this feature, we can provide some unique benefits which truly set Magnus apart from the competition. First, the ability to deactivate or turn off the pads, making the tool completely passive for all applications where directional control is not required, like drilling out casing shoes, tripping in, tripping out, or while reaming. Secondly, we have system redundancy. If one of the pads happens to go down, we have 2 additional pads to keep us drilling ahead, eliminating a trip. And third, proportional steering control. This means improved wellbore quality and less tortuosity by reducing micro doglegs in the well. Recently, on an offshore rig in Romania, Magnus RSS was deployed downhole for over 16 days, drilling a 9,249-foot section in a single run. The tool accumulated 311 circulating hours during the run, completing the section 9 days ahead of schedule and saving the operator over $2.5 million in rig operating costs. On its very first deployment in Canada, the Magnus 475 tool drilled 2 consecutive record-breaking wells in Notikewin formation, drilling the fastest and longest laterals in the field. I'm proud to announce that we've recently achieved a major milestone with Magnus, reaching 1 million total feet drilled. Impressively, this milestone was achieved in 2.5 years from the date of commercialization, which is unprecedented in the rotary steerable industry.
While there are multiple rotary steerable system providers, only a few can offer comprehensive drilling solutions to operators globally, based on a wide range of tool sizes, operational reliability, seamless VHA integration, remote capability, global experience, and a sound drilling engineering quality process. This approach has delivered tangible results to both the operators and Weatherford.
There, nobody's on the screen there for a second. All right, that was an awesome presentation by the guys over there at Weatherford. Guys and gals over at Weatherford, absolutely amazing. I'm really honored by that because they told me that they made that video specifically for this event, and I was absolutely blown away by the professionalism of that video. slightly impartial to it just because I thought it was really cool. I'm kind of a video guy, so it was really good. All right, we are on to the final portion of the show. This is the domestic operator panel. It's chock full because I sent out a bunch of invites, and I'm glad that I finally got so many people to be able to come on board with this. Y'all have no idea how hard it is to get an operator to come on a panel when you're not an industry association. You're just David Gibson, who live streams on LinkedIn. So this is definitely a treat for me, and hopefully it is for y'all as well. So let's put the thing up here. So this final international or domestic operator panel is brought to you by Tomex. Thank you guys over there at Tomex for being able to sponsor this. All right, let's get everybody brought in here. So I'm just going to start throwing everybody up on the screen. We'll do introductions in a second. There we go. It worked. All right. So we'll go around. Everybody kind of introduce themselves. Let us know where you work, what you do, and then we'll get started with some questions. I've already said it, and I'm going to say it again. I just commented like 100 times in the online portion. I want you guys to be the ones asking questions. The whole point of doing this live is so that we can interact and y'all can get your questions. You don't have to stand in line and wait on a microphone. You don't even have to get out of your pajamas. You can just start asking questions. These are drilling engineers that are here, ready, waiting to be able to help you learn something about their perspective of what took place in the industry. All right, so we'll get started with Dakota, then go to Joseph, then Fred, then Luke, then Katie, and then we'll end with Chris. Dakota, give us an introduction, please, sir.
Yeah, my name is Dakota Murdoch. I'm a drilling engineer for Ascent Resources. If you're unfamiliar with Ascent, we're a privately held oil and gas operator, primarily natural gas in the Utica Basin in Ohio. About 350,000 acres and 8th largest producer of natural gas in the country.
All right, Joseph or Joe.
Yes, sir. Thanks, David, for the invite. Informative as always. Joe Garcia, drilling manager for Camino Natural Resources. We're a fairly young company. We're backed by private equity. We primarily operate in the Merge and the Scoop in central Oklahoma. And most recently, I've got a rig drilling in the Delaware Basin in West Texas. Been in the industry for 26 years. My first experience with rotary steerables happened early 2000s, vertical seeking tools, drilling on conventional wells, S wells on the Pinedale Anticline in Wyoming. And then as unconventional drilling took off in the Marcellus, experience drilling with rotary steerables, drilling curved and lateral single BHA runs in the Marcellus.
All right, excellent. Luke.
Yeah, my name is Luke Beebe. I work for CNX Resources. We're in the Appalachian Basin, primarily Marcellus and Utica wells, Pennsylvania, Ohio, and a little bit of West Virginia. We are primarily rotary steerable for both those plays, and have been for quite a long time, probably since early 2010 or 11 or so. That's my background.
All right, Fred.
Good morning, everyone. Good morning, David. My name is Fred Fart, drilling execution lead for BPX Energy. As everybody kind of went over the company's portfolio, we got rigs running now in West Texas, East Texas, and South Texas. And currently I'm assigned to South Texas business unit. Most of my career has been in West Texas, and started drilling on the service side with Baker Hughes. I was told I was on the first auto track curve run in the U.S. land. That's what I was told. I don't know if it's the truth, but run that for a year and a half before I went over and came over to ConocoPhillips and Parcel Energy, now with BPX Energy.
All right, Katie.
Hi, I'm Katie Mills. I'm a drilling engineer with ConocoPhillips. I'm assigned to the Bakken. And then obviously ConocoPhillips is a big player in the Eagle Ford, and now in the Permian with our acquisition of Concho that we're starting to merge. So that'll be interesting. Yeah, so I started my career with Schlumberger in Mexico and ran RSS down there as an MWD and then as a DD. So that's kind of my RSS background. Yeah.
All right, and Chris.
Hi there, Chris Montan, recently with Marathon Oil. I've got experience in the Bakken, Northern Delaware area, and also the Eagle Ford. Currently, I'm kind of doing my own consulting work where I just left Marathon 3 weeks ago, so open to opportunities. And my experience with RSS is in the Eagle Ford, obviously doing vertical curve laterals, and then mainly in the Northern Delaware in the lateral portion of the wells. So excited to join the panel.
Well, again, thank you all for being here. So one of the hot topic questions that we have here, and this one comes in from none other than LinkedIn user. So LinkedIn user says, can some companies survive in the RSS world given current drilling activity? That is not the question I meant to click on. Sorry. Let me try this again. Okay, here we go. To all the RSS, how do you ensure wellbore quality improvement is done by RSS? There we go. That was the one I meant to click on. Dakota, we'll start with you, please, sir.
Yeah, can we pop that question back up?
Yes.
I need to look at that. Quality improvement, I mean, honestly, from a smaller U.S. land operator, I'm relying on the service company. I'm relying on them to bring me the best product they have and the best improvements they have. And then obviously we're, pushing them to improve in terms of just the ability to be in our wellbore, that's the main stick that we have to drive improvement is whether or not we put them in the hole. But yeah, that'd be my answer.
All right. Well, then going from somebody small to a little bit larger company, Katie?
Yeah, it's a good question. I mean, I think for us, some of it comes down to like during the drilling cycle, we're focused on trying to make sure that we've got our bit and our RSS kind of paired together well so that we know that we're not going to have any issues with, overgauge holes or, porpoising. That's a huge problem with RSS. I'd say kind of on the other end of stuff, how we prove that it's a really long cycle, right? There's a lot of companies that spend the time to go back and look at number of workovers and specific repairs and casing wear over time. We're not great at doing that. I wish we were better, and I think we're getting there. And that for me is like one way to really prove that okay, the RSS is worth the whole quality is if you're able to go back and prove that the money was worth it. I mean, I guess there's some other stuff that we can do, running calipers and that kind of stuff, but realistically, it's not very common for us to do any of that work.
Okay, Joe, we'll jump over to you. Same question.
Yeah, I think rotary steerables and hole quality is synonymous, right? That's what you get with the technology. That's why you're paying for it. And then, so basically it boils down to is dogleg severity management, right? Down the lateral, if you can do some turning out in the lateral, or if you're going to drill a directional plan with prescribed take points, or are you just going to stay within a 5 or 10 foot window within the reservoir? Ideally you want to put your well in the best rock, and then therefore you're going to follow a reservoir. And so dogleg severity management is probably the next best course using the technology. And can that technology achieve those dogleg severity requirements?
Fred, we'll jump over to you for the same question, please, sir.
Sure. It's kind of twofold, or probably the continuation of that question was how RSS compares to conventional, right? That's really the underlying question. So with the RSS, as Joe mentioned, you got the technology, you got more near bit inclination, near bit azimuth, you constantly monitoring that wellbore quality, the tortuosity is lower. And comparing to conventional tool, you don't know really what's going on until take a survey 40, 90 feet later. But with the RSS, you have that ability to control. As Joe mentioned again, you can lock it in can as, depends on the system, stay in a 2-3 foot window, which is almost impossible with a conventional tool. So those are the stuff that almost impossible to be done with the conventional, but the RSS make it happen. And as far as the quality of the wellbore, you have continuous real-time monitoring of the tortuosity. That's the ability that you get with the RSS system.
So Luke, I want to be able to come over to you with a similar question, but slightly different. Is there any collaboration between the completions team to ensure wellbore quality over the life of the well, and obviously in consideration with having to use an RSS system?
Yeah, there definitely is. Joe mentioned managing dog legs. The benefit to a lot of these rotary steerable systems is the ability to put out high dog legs for the curve and then keep it in the hole to drill the lateral. But if, we've seen in the past that if we don't manage those dog legs in the lateral, and especially as we're increasing lateral lengths, getting out 15,000 foot plus, that can create a major issue for the completions guys with wireline ops and everything else. So yeah, there's definitely a lot of collaboration. I know we track dog leg severity in the lateral as kind of one of our major metrics for our rotary steerable providers, just to ensure that we're not causing issues for the completions guys and then ultimately the production teams, who we're kind of drilling is kind of a service to those people as well. So we got to do our part to make sure that we're not making their jobs more challenging.
All right, Chris, I want to jump up to you with this one. Clicked on the wrong one. There we go. What do operators look for beyond the features offered today from all of the RSS available in the market?
Yeah, so I just want to touch on the last question a little bit.
Yeah, go ahead. Go ahead.
Yeah, so, recently, probably actually like a year ago, I was involved in a 5-well pad that we were drilling, and we did conventional versus RSS on them. And honestly, the biggest takeaway was the casing running time that we saved on wells that were drilled with the RSS. And I think that's part of the equation. If you're in an area where it's difficult to run casing, how much longer did it take you to run that production pipe versus, wells drilled with motors? And there's other obviously factors involved with that, but that was kind of a big, take that we had from that. And then as far as, dealing with the completions or the production team, obviously keeping the dog legs as low as possible down to kickoff point is something that we always achieved on, and that'll actually improve the life of ESPs and other, production equipment that you need for the life of the well. So making sure that you're minimizing those dog legs throughout the verticals, something that we really focused on, and I believe is a very important characteristic of building a wellbore. So, and then David, if you could bring up that next question.
Let me see if I can find it real quick. Here it goes. What do operators look for beyond the features offered today from all the RSS systems available in the market?
Yeah, I mean, everybody's touched on it, right? Reliability, making sure whatever you put in the hole is going to do its job. And at the end of the day, that's what we're all looking for, is something that you can count on. Or if you can't, someone that's going to be able to fix that problem very quickly. And I'll just keep my answer short at that.
What's the best way for a company to be able to convey the reliability? Coming from an MWD background myself, you could say MTBF, but MTBF can be measured in multiple different ways.
Right.
So if somebody is a new company or they've had work with another operator and they're trying to come over, what's the best way to be able to convey that information to you?
I would say, something that I would look for is, okay, how many new customers have you gained? And how many customers do you have now? And is there a big loss of customers? Because to me, if you're keeping customers, that shows that you're staying in the hole, you're being reliable, or you're working on things to become better. So that's the way I would present it if I was an RSS company to, try to acquire another client.
Anybody else want to jump in on that one?
Sure, David.
For me, it's being transparent, showing all the data. Sorry,
Joe, go ahead.
Sorry. Yeah, for me, it's just being transparent, showing all the data, right? Data doesn't lie, and evaluating the economics and risk associated with that data. Sorry.
Go ahead, Fred.
Yeah, the one I wanted to add, again, previous position, we had a cutoff, again, to be or not to be RSS or conventional. It was always the question, what is that threshold that really not yielding a lot of gain. So that would be that threshold. We determine that point. Is it number of failures, number of one runs? Depends on the lateral length. All that stuff again is going to the consideration. Okay, what is that sweet spot? What is that founder point that okay, now RSS doesn't make sense, or yes, after that point, conventional maybe is a better option. So those are the stuff that kind of again is going to be case by case, area by area, almost well to well, determining that point. What's the the recovery factor? If we trip, is it makes sense to go back with a conventional or not? So anywhere I've worked, different operators, we had that cutoff line, kind of determine RSS or conventional. It's usually a clear line in most of the cases.
So for the panel then, this is kind of a pretty typical question. How do y'all and your organization in your specific areas go about evaluating whether to use rotary steerable or to use a conventional system? Feel free to jump in.
For us, we've studied this, as long as I've been a part of the company, so 5 years. It's a recurring question, as technology continues to develop. So the biggest three things that we look at is, everyone said it: reliability, performance, and then total cost to drill curve and lateral, which is where we're running rotary steerables. So reliability, it's sharing all of those reliability numbers, or if we've already had it in the hole, evaluating our historical performance with that tool, both conventional and rotary steerable side. And then on the performance side, earlier on, a lot of companies wanted to talk about, average ROPs, but it doesn't have the detail in it that you need to really make that decision. So, we break down our EDR data into essentially averages per stand over the course of variable lateral lengths. What's effective in a 10,000 foot lateral versus what's effective in a 20,000 foot lateral can be very different. And so, basically taking that EDR and performance data and translating that into time and ultimately cost to drill, to basically say, this type of lateral length, this is what is expected, and so on.
Hey, David, I'd like to offer a little different perspective as well. So,
yes,
a lot of it, what drives the use of rotary steerables over conventional tools for a small operator like Camino is risk versus reward. Okay, so if, for example, if you're an operator drilling in a basin like the Marcellus, for example, drilling single curve and lateral runs, you're drilling over a mile a day. Heck, they're even achieving 7,000 feet a day on a regular basis. Or you're in the DJ Basin where you're drilling, out of the chute to TD and in one run, and that same BHA could probably drill multiple wells. The reward is going to outweigh the little risk that there is. However, if you're in a basin, for example, like the Scoop where we operate, you got deep TVD wells, 16 to 17,000 feet TVD. The Woodford formation is a primary objection here, and you have chert nodules and lime streaks, and you've got multiple BHAs in a 2 mile lateral. Up to a dozen BHA runs, and then the tangent, you got known wellbore stability challenges there in the lateral. You got significant faulting, can throw you up or down section 90 feet, and you got to get those packed BHAs through those faults. Your risk goes up significantly. So, and then if you're a bigger operator that got a rather large CapEx, and you got a half a dozen rigs or more in those challenging environments like the Scoop, you're probably willing to take a little bit more risk on, right? Versus a small operator where you may have a CapEx plan for 1 or 2 rigs. A planted BHA, a multi-million-dollar BHA in a hole, has a significant impact on our rate of return. And so, being a private operator, we have to spend our equity partners' money wisely. And so, we found we got burned early on because we were chasing that reward. As an engineer, you want to chase a reward, but as a manager, you gotta manage risk, right? And so, those are some of the nuances of different areas and running this technology.
Anybody else want to jump in on that one?
Yeah, I guess, for the Bakken, we typically, RSS, it's not an RSS field, right? Like nobody uses it except for kind of individual use cases. But we did have some high tangent angle wells recently that we evaluated and used RSS on 5 of them. The tangent angles, we went from 0, stepping up all the way up to 42 degrees. And so, you know, everything over 30 degrees, basically we used an RSS on. And so like a big part of our analysis on that was the, you know, the cost and a breakdown of basically like what we thought it was going to take to do that with a motor. And we kind of were able to show that about per 1 degree of tangent, we would expect about an hour of sliding. And so we kind of used that to break it down and look at, you know, okay, well, what angle does it make sense to start using an RSS? And we found that to be anywhere from 18 degrees to like 28 degrees, depending on your metrics and stuff. And so that I think is a rule that we'll use going forward. Our RSS trial was a bit of a mixed bag because, you know, durability in the field is a problem, right? Like it's a really tough play to get an RSS through. So, so yeah, that's kind of how we like go through and do selection on when we're going to use RSS. And I think that will carry forward based on kind of what we did on this last pad.
All right, Luke, Fred, or Chris, y'all want to jump in?
Sure, I'll go ahead. Yeah, especially expand on what Katie mentioned. Same thing. We had, again, operation in 3 different basins, BPX. So South Texas, it's pretty much dried up on RSS. Weatherford was the, I would say, only player in the RSS field. They pulled out of the U.S. market. So really that option is gone due to the high temp. So we're really kind of limited in the South Texas. We're exploring some options. There are some other vendors that we're working with trying to kind of combat that high temp. So right now, it's not really an option, reliable option in the market for Eagle Ford. But in the West Texas side, again, as Katie mentioned, depends on the side of the step outs and again, risk and reward. As Joe mentioned, we're looking at it, how the conventional performed and is the RSS applicable in that specific wellbore specific area. So it's area to area, but unfortunately in the Eagle Ford side, we're kind of handcuffed and looking for options now. Again, it's going to be tough to beat the motor performance. They're performing really good compared to even later performance the Weatherford rotary steerable had. Right now, I don't think even they can beat the conventional. So we need to find the next generation of rotary steerable that can handle the temperature and at least match the performance we get or better than what we have with the conventional tools in Eagle Ford.
Excellent. Thank you for your response. All right, guys. So here, let's switch gears just a little bit. We've got a question here from somebody out there watching. To the panel, what is your comfort level or willingness to push remote operation utilizing RSS or any directional service? Luke, you want to jump in there?
Yeah, I can take that one. So I mean, that's the way it's heading, right? But I guess from the operator side, and you know, where at least where I'm at with it is, we've got to take it in steps. You know, I think it's easier if you have multiple rigs operating close together. You know, I think, you know, pulling off maybe the night hand or an MWD hand, but still having somebody close to site that if they get into an issue, somebody's there pretty quickly. You know, I'm personally not to the point of being comfortable going full remote. I think there's a lot of risk on the operator side if there's an issue, a communication issue, a tool, you know, trying to diagnose an issue. You know, hours cost us a lot of money, and I think, you know, I think we'll get there, and you know, some companies are doing full remote, but I think we just gotta. For me, we got to take it slow, and I got to get a little more comfortable with it.
Chris?
Yeah, so just to kind of add on to what Luke's saying, it definitely puts more pressure on your guys on the rig, on your consultants. They have more responsibility. There's more things to watch, whereas if you have a directional guy there, you know, he's obviously kind of in charge of that. And then when he needs someone to speak to, he's having to call in the remote team. But you can build it and it can happen, but you need the right people making sure that they're able to watch the work that's happening, and also just making sure, honestly, this brings a point where the actual driller from the contractor is having to do more things that's kind of not in his scope of work. So it'll kind of be interesting to see how this all unfolds with the, drilling contractor saying, hey, this is not part of our, our driller scope, putting in slides or having to put in downlinks, independently, and whether there's any pushback on that, without a directional guy there is going to be interesting to see how that kind of unfolds. So.
Anybody else want to jump in on that one?
Yeah, before I leave this industry, I'm going to have 6+ drilling rigs with a real-time operating center just across the hallway. At some point, I mean, we're on the cusp of it. I know XTO, some of the big boys are doing it today in their own real-time operation center with geosteers, team of geosteers, engineers. Yeah, it's going to happen. So I look forward to it.
Yeah, David, I want to add again, going back to my point, pros and cons. Okay, what are we gaining? What are we losing? So as far as the cons, again, we're in an industry, face-to-face interaction, valued in the field, and the guys out there want to have somebody to talk to. And if you come to the troubleshooting, that's what really everything is going peachy. Everything is fine. There's no need for that interaction. But that's when the trouble starts. They want to go to somebody face-to-face versus, as Chris and Luke mentioned, pick up the phone. So the pros, I mean, there's a lot of pros to it. As Luke mentioned, if you have a bunch of rigs in the same area, you got a DD, it's a jam of hand, he knows what he's doing. So you sharing that knowledge, that consistency with that 3-4 rigs, versus if you have 6 different directional drillers with different set of skills, really you don't know what you're getting. But at the same time, again, rotary steerable versus conventional, personally, I would not feel comfortable with the conventional side to be unmanned, but the rotary steerable, we have done it, previous operators successly, and I don't think we lost a lot. We gained a lot as far as the consistency and performance goes, because again, you have one guy that he's watching 3 rigs, sharing knowledge on all that stuff that going into that. So that would be my take. Again, case by case, conventional rotary steerable, I definitely more comfortable on the rotary steerable side, conventional, not so much.
Katie, you want to jump in? I know that one of your offset operators there has been famous about as far as what they've been able to do there in the Bakken.
Yeah, and we've actually been emulating what they've been doing. So the last 2 years, we've been working towards remote operations. And so we stood up a real-time center right down the hall. And we are using remote operations with conventional day in and day out. A lot of it has been leveraging technology from our drilling contractors. So we tested both H&P and Neighbors systems with, the auto slide and smart slide. They renamed it, but it's smart side now on the Neighbor side. And we've had mixed success with both of those, but we've really been able to leverage like what our offset operator has done in the basin to kind of get us a little bit further. I think the Bakken is really lucky in that we have a really strong kind of committee of operators that collaborate together through our rig contractors, and so it's really been helpful that we get to share lessons very directly. And then from our side, we've actually been able to take those straight over to the Permian and get them kind of up to speed on remote operations and using conventional motor technology for remote operations. And so yeah, it's something we're moving towards. I personally think that it's the future. I think COVID taught us that, right? Because we had outbreaks on, I think every rig at some point. We were like, okay, if we don't get people out there, right this minute, we're going to have to shut things down. And I mean, at one point I had my RSS hand, steering from quarantine in a hotel in Watford City because like we were trying to scramble to find hands. And so I think I think that this is going to be something that we're going to see more and more as people are having to do things from different places, just with the way the world is right now.
All right, so I have to ask this question. It's been coming up a bunch. Whoever's asking it, here we go. Has anyone actually compared RSS to open hole condition using caliper logs to lay out facts from data? So has anybody used caliper? There's your answer. Okay, so on to the next one. So I did see one question in here earlier. I can't find it at the moment, which was when we were talking about reliability. That's come up a lot. Should the reliability of a mud motor versus RSS be equivalent, or is there any kind of level of disparity between those two where you hold the standards to? Chris?
Yeah, I would say you've got to figure out what your pace is with each tool, right? And then you can figure out, if I have this amount of downtime and this, and what I'm paying for the tool, there's a calculation for that, right? And you can give a little leeway and have some more NPT unplanned time plan for the RSS if it's outperforming your motors, right? So it just kind of depends on the economics, and that's what we're all paid to do, right? Is drill a well as cheaply and efficiently as possible. So.
All right, anybody else want to jump in on that? We're getting here pretty close to the end of time, and I don't want to cut off everybody, but anybody else?
I don't know if I interpreted that question differently. I was thinking about it on the aspect of tracking, the motor behind my RSS's performance along with RSS's reliability, and that is something that we track separately. I mean, ultimately, the vendor is held accountable whether they have 10 motor failures or 10 steering head failures, but I would say that we do consider that a little bit differently if it's a motor problem, especially a third-party rented motor problem.
David, to add to that and Chris's comments, again, we got the day rates, totally different world. So that will go to the calculations and economics that Chris mentioned. Yes, the conventional has a little bit more cushion, honestly, as far as more forgiven, as far as the trips and failure rate. RSS not so much. It's not a fair competition there, but again, at the same time, to offset that extra cost, the daily cost we're paying. And then on top of that, there are wells profiles that 100% require rotary steerable. There's not really a good option. Then those are the cases, no brainer, just go straight to it and hope for the best. And you're in the mercy of the vendors that they keep their tool up to date, their QA QC processed in checks, and they're really maintaining those tools properly. So again, some cases you have to, there's no option. Some cases that you have, it will honestly favor on the conventional side over the rotary steerable side.
All right, one last question I'm going to throw out there for everybody. Do you find RSS mesh better or worse with geosteering over conventional assemblies? Donnie Fulton, thanks for the question, sir.
Yeah, I'll take that one.
Yeah, thank you, sir.
So I think, the basin we operate in, Marcellus, Utica, I think, to be honest, it would be hard to go back to a conventional assembly and steer the wells to the same standard that we're steering them today. With the small target window that we have, the long laterals, the focus on, like we've talked, wellbore quality and tortuosity for completions ops. It would be a challenge to go back to a conventional motor, being 30, 40, 50 foot back from the bit trying to steer a well.
Agreed. Inclination.
Everybody's shaking their heads.
Close to the bit. Yeah.
All right. Well, we're finished up here at the end, and if we don't stop before 4 hours, LinkedIn just turns us off, and then anybody that's watching on LinkedIn will just be lost, and people on YouTube will be like, hey, where'd the rest of the audience go? So I have to say this. Thank you so much to Chris, Dakota, Joe, Fred, Luke, and Katie. Thank y'all so much for being a part of this. It's easy to be able to get companies to sign up and be a part of, or service companies to be able to sign up and be a part of this, technology providers to be able to do it. It is almost nearly impossible to get people from the operator side to join in on this, especially since I don't really sell to the operators. I mean, I'd like to, but I don't really have that many relationships with people on the operator side. So I thank each one of you very, very much for taking your time to be able to be a part of this and to be able to provide some information back to the community about y'all's thoughts and feelings of RSS. So thank y'all so much for being here today.
Thank you.
Yep. Thank you, David.
Thank you, David.
Well done.
All right. All right. So I'm going to do this real quick. All right, guys. Now it's time to give me some feedback. I've got about 1 minute and 30 seconds left. It's done. Remember, hashtag Gibson. All right. So yeah, I want to be able to get y'all's feedback on this. This is the very first time me hosting a conference. Anything of this magnitude, having to put this much energy into something. So I want y'all's feedback. Do you want to see me do something like this again? If you don't, tell me. Harshest criticism possible. Like, I am not going to get my feelings hurt. I want to get better. Plain and simple. I don't care what you say. I don't care how mean it is, whatever. I will take in whatever it is. Critique me, give me 1 star, give me no stars, whatever. Just tell me what I did wrong, what we could do better. What do you want to see more of? Do we need to get more questions in? Less companies, more companies? Does it need to be longer? Does it need to be a 2-day event? Whatever it is, please let me know. So we got a ton of comments. The RSS event of 2021. So Martin Hayes, thank you so much for that, sir. Andrew Quinn says, great panel discussion. Thanks. Yeah, guys, let me know. Like I said, this is my very first event. I got about 30 seconds again before I get cut off by LinkedIn. If you guys want me to do another event in the future, what topic? What should it be? Managed pressure drilling? Should we do drilling software? Should we go over to the completions and frac side of the business? Should we talk about ESG, thermal, renewable energy, whatever? Y'all are the audience. I've put together all of this stuff, and we're about to get cut off. So thanks everybody for watching. I appreciate it. I think we just lost everybody on LinkedIn. I don't know. We'll see. Hey, if you're still watching on LinkedIn, let me know. I think it's supposed to get cut off. At least that's what I was thinking. So yeah, you guys out there, whoever's still watching on YouTube can still at least comment and let me know. Guys, let me know what y'all would like to be able to see. Oh, it's still going?
Oh, wait a minute.
Well, there's a 30-second time delay, so
Okay. All right.
we'll see. Get a better camera so you don't have to use your fist bump to get in focus. Yeah, it was because it was set on autofocus, and so it was like if I wanted to move around. But yeah, I could just set it to where I'm supposed to stand in one spot. Still here. It's still live. It's still live on LinkedIn. Are you kidding me? Oh my gosh. Well, maybe there's a time delay and some of the people are saying, okay. Well, anyways, guys, yep, there it goes. LinkedIn's done. So everybody that's still watching on YouTube, guys, reach out to me. Let me know, give me the thumbs up, thumbs down. Let me know what topics you guys want me to be able to do next. I really appreciate everybody's support out there for all the companies that took part. Let me read them off real quick. DTech, Rival, Tomax, Kinetic, Sparrow, Scientific, Scout, CT Energy Services, Schlumberger, Cougar, InTech, Wolverine, Compass, Baker, and Weatherford, and last but not least, Gibson Reports. Thank you to my mom, Red Flyer Media. I love you, Mom. Thank you. Thank you to my girlfriend, Jessica. Jessica, thank you so much. Thank you to my brother, Russell, for helping out so much with the kids here lately as I've been working nonstop. Thank you. I love my kids, Brooklyn and Weston. Thank you, guys. That's it. I don't have anybody else to thank. That's it. Comments are pretty much done. They're still coming in because people are probably watching on a time delay, but that was it. All right. It says that there's still people watching on. Oh, it's 3 people are watching on Facebook and 98 people on YouTube.
Wow.
Wow. Guys, thanks. Appreciate it. All right. I'm going to shut this one down. Where is the button to do it? Oh, did Jonathan Lightfoot just comment? Hey, good job, David. Thanks, Jonathan. I appreciate that. It's like, it means a lot to me coming from you. All right. All right, guys. That's it. Let me know what y'all want for the next one. There's the button. And as always, know your industry.